Hi. Oh, I see there's more people now. Nice. Okay, before I start, let me check that the streaming on YouTube is working. And then I'll start. Oh yeah, it seems to be working. Nice. So open this one. Yeah. Okay, yeah. So this paper, I just picked this paper because Burley mentioned it on the channel, and I want to also do at some point the new one by Neil's math students about interpreting chain of thought and all that, but I'm going to see if I can get the authors for that one. So in the meantime, for this week I didn't have that much time, so I just picked this one. Yeah, I haven't read it and don't know much about it except that what they say on the. I mean, we can read it now. But it looks like it's about it's reverse engineering a tiny transformer model paper. Which
Yeah,
is nice.
your mic started glitching,
Uh,
so it's
uh,
not just on my side.
Now.
Just try to talk.
Does it work now or still glitching?
Yeah, now it seems good. Okay.
Okay. I think it might have been my internet dying for a moment or something. If it keeps happening, tell me. I maybe can switch to my phone data and all that. But otherwise, damn.
Okay.
Yeah, never mind. Just tell me if it's happening again. But anyway. Oh, by the way, have you read the paper before, or did you just
Nope.
look at it? Okay, yeah, we'll read it now, I guess. I
I was
because
basically yeah. Well, yeah, I was just basically looking for similar papers where they try to, something like the Grokking Modular Edition paper where they have some transformer from scratch
yeah,
as reverse engineered as possible on some toy problem. And this is one of the papers I found basically.
yeah. I'm interested, like, yeah, how many papers are there apart from the Neil one and mine, and like there's probably a few more, but and
Yeah.
I understand why Neil is less optimistic about this kind of things. Generalizing. At the same time, I feel like some of the modular addition stuff is generalized
not
too.
optimize, not what topic is he not as optimistic
Oh,
about? I can't see the paper.
it's about this kind of very small toy model of an algorithmic task, generalizing to bigger models.
I feel like he's fine with it if he had a proxy task to show it could be generalizable or show something about it.
Yeah, I guess. I think depends, but yeah, I guess you're right in that he would that's not exactly what the pragmatic interp thing says, but I do think over time he's has said elsewhere that he's not that thing. This kind of algorithmic toy test is less interesting. But yeah, at the same time, I don't think people have actually tried this that much. I also I feel like a lot of I wouldn't be surprised if a lot of this kind of research was done in like people's early before Neil started not liking it as much and saying things about that. Like early maths application to Neil stream and were never published. Uh, and yeah. Yeah, let's read the thing. Well, I do have an extra thing to say is that I think that I noticing that Claude 4.5 Opus is like like still not good enough to do it independently, but not that far away from being able to figure out some of these your reverse engineer very tiny models. Because it's the kind of task where you can just run a lot of experiments. Like when you run experiment, take the results, look at them, then make also another experiment. And did you
Yeah,
mean to say
this might be this might be a topic for later, but what I'm thinking about that maybe we could make some Mech Interp skills for Claude that might make it much better at that. Maybe
Oh yeah, I
inside
do
Claude code.
notice that it fails at like it's I was trying that that to have a model like the for the model multiplication thing. I mostly has reverse engineer. I was trying to see like you will come up with the same things as me, and I feel like it's missing some kind of knowledge that and ideas that I have that I didn't have before I started doing that kind of research. And when it's about thinking certain ways about the problem and like what kind of hypothesis makes sense, and maybe this is just a question of making a prompt or something. uh,
Yeah, maybe not. Maybe
and it
it's
also has to be told to do things like it can do things like patching, which could also be a thing. Uh,
yeah, having
otherwise,
collection of Mech Interp techniques in context
yeah,
window
I
basically and
feel like
best
otherwise it
references.
kind of tries. It does a thing when it looks for a correlation. Like it tests two data. It tries to see do things, two things are similar. Find something that is correlated in the both of them. I just think it has explained it. To be fair, I also was doing that in a very long conversation, and maybe it's just that it did it once and then it started doing it more because it wasn't the context or whatever. Uh, but yeah, anyway, let's actually read the paper. Sorry, I guess we can later talk about Claude or whatever. We study how one layer attention only transformer develops development structures while learning to sort lists of numbers. Another train, the model organizes attention heads into two main modes that refer as vocabulary splitting and copy suppression. Uh-huh. Both represent simpler modes that having multiple heads handle overlapping ranges or numbers. Interestingly, vocabulary splitting is present regardless of whether we use weight decay, a common regression technique thought to drive simplification. I mean, yeah, supporting I think that there are this already shows on the I think on the Niels Crokin paper and all that. There are other even if you don't use weight decay, there are other pressures for the model to find simple like it's already part of the there are some implicit priors on the transformer architecture that make it more likely to find, and the way the references works would make it more likely to find simple programs that memorizing everything. But yeah, we relate copy suppression to a mechanism in GPT-2 and investigate this for error in a model. That's actually interesting. Like, it's nice that to do this kind of small model research and then look into GPT-2. Which, I mean, in some other contexts, it's a small model, but if you are looking at a one layer transformer, one layer attention only transformer, like GPT-2 is giant compared to that.
You started glitching again.
Let me. Okay, I have an idea. In case if it's just cutting, or does it do something like that's more like it's losing connection?
It's not like
Feels
it's
like losing
cutting.
connection.
It sounds
Okay,
more.
I can
It
fix
sounds like a
that then.
distorted voice. Yeah.
Okay,
Yeah,
yeah,
it's
that's
connection.
probably the
Losing
internet.
packets.
Let me just switch to my phone, where it, I can just use my phone as a Wi-Fi zone or whatever, and then. Moment. Wait, what? Oh, yeah. Yeah, I'm going to have. Yep. Choose. Okay.
Mm-hmm.
Could you try speaking again, or is the mic still broken?
Okay, let me. Yeah, let me. Does it work now, or are you still hearing it weird?
I hear you right now. I just hope it just doesn't glitch out later. We'll tell you if you
Yeah.
glitch out later.
Now the
Okay, yeah.
voice is.
Tell me
Yeah.
later
Now
if it.
Yeah. Seems good.
Okay. Okay. Yeah. The only problem now is that I had to, since I had to change internet, I have to close. Let me put the stream again on the recording. Okay. I want to make it bigger, but I'm not sure how. Like I
Maybe
know doesn't.
F11 would make it bigger. Not sure if you can do F11 there, like full screen the whole tab basically.
I'm a little curious for this experiment. Do they like simply like after a certain amount of training steps, they decided to look at the attention head and see how the head has like changed? I assume. I'm curious if like they tried showing like instead of just the training steps, also tried showing it with different. Oh yeah, they did show with instead of the one learning rate, they're like doing like different learning rates and seeing the number of training steps. So maybe like the progression is different if there's a different learning rate. Does it show like the model breaking? for the vocabulary splitting, for example.
Doing pass through different learning rates sounds interesting.
No, because they only did one learning rate right now, and we know that like if we do a higher learning rate, like the model could break, right? We could break the model, or like the model doesn't learn it. An example could be seen with like relearning, where like if the learning rate's not high enough, the relearning doesn't occur. So I'm a little curious. Instead of trying to look at the training steps, only the training steps, I wonder what would happen if they tried looking at cross different training rates, learning rates, without them optimizing.
I didn't, because it's I think it's maybe not even Discord. It's maybe like not my internet. It's maybe like the.
But we could hear
whatever the
you. We could hear
nearest
you right
Discord.
now. We could hear you though. Can you hear us?
Yeah, no, I know. I can hear you now, but there was a bit where it was not working. And I just only noticed you were talking because I was checking the recording, and then so you were talking there, but I missed most of what you just said. Sorry.
Okay, so my argument, or like what I was curious about for this paper, when looking at how they looked at seems like they looked at the different set of training rate, and then they looked at the number of training steps. And it seems like after like a certain amount of training steps, they like looked at the model and looked at the attention heads to confirm how the attention head like progresses throughout the model. Instead of like doing these large like training steps and with one learning rate, I'm a little curious if like increasing the learning rate or decreasing the learning rate, if this like progression in the heads, attention heads development like is different. Like maybe like with a low training rate, like with how it's difficult for the model to relearn, it might not have an effect. With higher learning rates, you could see the model progressively like overfit and break. Because they only did one learning rate, so like I feel like one critique is like maybe this is only for like this one learning rate they like hyper specific like optimized and looked at. I'm a little curious, like looking at the attention heads for like other learning
the
rates.
problem with this kind of thing is so you do this kind of research and you spend a lot of time trying to reverse engineer a tiny model, right? And it can be the case that you train it again, even like with the same learning rate and everything, but a different seed, and then it learns a different algorithm. And it's just too much work to figure out for a lot of things. You
Yes,
can be
but I'm
lucky and
saying
turns
too
out
much.
it just does similar things for all of them.
Yeah, but like I'm saying this could just be the case of this only works at this one specific learning rate they did. That I'm not sure.
Yeah.
Like if you wanted to like confirm the results, I feel like somebody else trying to do something similar but with different learning rates could confirm if this is like an actual part of the model. So far, I currently think this is very likely with how the heads seem to progress. With you can see the steps like going to like the list vocabulary vocabulary splitting head and also the copy suppressing head. So I feel like those, since they exist in the bigger models, I feel like this is like a natural progression. But I'm not 100% certain about like they seem to have done it like every like
okay, so this kind of thing where this progression, like I do agree, like if you train it with more or less if you train it with different learning rates, it's probably, even if it does learn the same things, which it might not, it might learn in a different order, or like the phases are faster or something, or they kind of overlap in different ways or whatever.
Yeah, and also like they seem to like, from the images, they seem to have like looked at the training steps every like 50. They look every like 50-ish to like observe the model, or something like 10. Like looking at the images, I'm assuming they're like doing every 10 or like 50. Or maybe like they are doing it after like every power of 10 or something.
Yeah,
I don't know if they're looking at every single like 10 steps or something, but like this, like
it's very hard to do for all steps this kind of thing, because you need to save all of the steps, right? And if you are not doing some kind of fun, there is no really fancy way of doing it. So you basically it takes a lot of gigabytes on your computer and you run out of memory. Like my experience trying to do this kind of thing, you run out of memory pretty hard. So you need to do something like only every whatever number of steps, and you can't do one step.
I know you could evaluate every something steps, but like they didn't really say how often they looked at it. That's what I don't know from the paper.
Oh yeah, that's they probably should do that if they didn't.
That's one critique. Like they didn't really tell their methodology for how often they're checking and also when. Because if they only
Wait.
it could be possible they just picked 4 parts of the model and looked at them. I doubt it, but it's possible.
On the stream, it's you have to reload the stream. The screen share on the stream, on the YouTube stream. You
Oh
have
yeah,
to reload it.
it's broken again. Okay, let me fix it. Close stream. Yeah, no way. Today it's not working very well for some reason. It's working now, right? Yeah. Oh wait, maybe.
Yeah, now it seems to be working, I think.
Okay, it's working now.
Yes.
Yeah, never mind. Anyway, what was I saying? Yeah. So
Not saying how often they look at the different snapshots.
You can look at number 4.1 and see how they chose the different developmental stages they showed. They seem to have used like a change in the gradients, the theta r, delta r, in 4.1. Yeah, like they look at the change in diagonal values in order to detect for one of them. To like determine if it was outside the
this kind of
developmental.
looks like there is some. This kind of
There's
looks like
like
there is some periodic structure thing here.
It looks
Another
good.
one to the
Like
collection.
I just feel like their details are not given for how they implemented the diagonal, like for example, the diagonal values, like determining the diagonal value differences for the boundaries of developmental stages. That's kind of iffy. I'm not 100% sure because they didn't explain what they did. Okay, they said they follow another paper, but we don't know exactly how they followed it. Did they follow the exact same thing? I guess Hoogland is also at Timeus, so it's possible they just use the exact same thing. Oh, you're glitching again.
Yeah, I try switching internet and it's still glitching, so it's not. I now with my phone yeah, I'll guess I'll deal with it glitching sometimes. So yeah, feel free to talk more if I not.
Also, 2 questions that I this paper. So they have done only a one layer attention only transformer model. So my question was, did they like show why it is relevant to just look at a one layer model? Like, is the behavior the same when we look at multiple layers? Does it change?
I mean,
Another question I
they
had
do
was,
look at. They do say, at least on the, I haven't read it, but they do say there is, they relate the mechanism to a mechanism in GPT-2 at least. I think the thing to look into for a one layer transformer is that it's easier. I think in practice not that easier, but it is in theory easier to figure out how it works, and maybe it generalizes to bigger models. I I don't know. I think there are reasons to believe that it won't generalize, but at the same time, for example, I think the modular addition thing
Mm.
from Neil did lead to like people figuring similar things out on GPT-2 and bigger models, which is also related to the newer anthropic thing with the low, well, all the spirals and the the low dimensional curves and all that, and that's all related. And I'm not sure that the actual Grokking model actually does the kind of spiral thing, because I think it's learning something more specific where it's with the Fourier thing, it's more like it's taking a few discrete things and taking the modulo or whatever. But yeah, never mind. I don't know. I think it could be interesting, but it also could turn out that the one layer models are just very different from realistic bigger models, and you don't really learn nothing super interesting from them. Was that like what you were thinking about? Or...
Yeah, that is what I was talking about. Thanks for the answer.
Yeah, okay, yeah. So my answer then is I don't know, maybe. They claim they do find something in GPT-2, which is nice. Yeah, I do think in general, if you do this kind of research, you should be trying to see how it generalizes to bigger models. I say this, but I did publish a paper of this kind of research and then didn't manage to do that. So. uh,
I'm not sure about how they detected the boundaries between the different learning stages, because they talk about how they use the gradient difference, but they didn't talk about like how they measured this, because they didn't specify how often they measured the attention, because like maybe like increasing the number of steps will make it harder to find between training steps between like evaluating, because they don't give either of those. So like those are two iffy
Okay.
parts of the methodology.
I guess I can read the. If you're question about that, I can read the start by reading this part. A common developmental stage course that could be more versus on fit. Also, they did trying a few more and look at it, which is nice. Initial learning causes by rapidly decreasing loss and increasing head overlapping where word heads appear and completely partial overlapping vocabularies and head expressions in traits. There are some stations. There is no head overlapping traits with training without layer norm and with decay. And there is no head expression in the one head for the one head model. Yeah, the layer norm, I'm assuming that's better. And does change thing on the tiny transformers a lot. I mean, it's also a technically non-linearity, so it lets the model do some weird things with it. But yeah. It chooses the boundaries of the perimeter state, matching several factors, most related to significant changes in the measures of the patterns of the OB and KQ circuits. They are visible to the eye. In the case of the loss and the complexity measures, a significant change causes variations in the steepness of the slope versus the slope. Okay, yeah, I feel like they were actually just looking at a few plots and doing it by eye. Yeah,
I'm saying that's the vibe this paper is giving me, because they don't specify the number of steps they used to determine it. So maybe they did. They just did not show their work.
Yeah, I mean,
And depending
I
on
think
the
makes sense to that though. Like,
and depending on the number of steps that are different, like how are they determining the gradient difference? Because are they checking it between every single step, or I don't think that's possible. So I'm assuming it's between these arbitrary sizes of steps they did in order to determine if it's a boundary, which is kind of, I honestly feel is very iffy for methodology, or it's hard to reproduce. So yes, I think it's interesting what they did. I think what they showed for this paper is very likely to be true. Just I feel like they didn't explain their steps to get it fully. Yeah, but I find the idea of like generalization and specializing for the attention heads to be interesting, and I think that could be tested for larger models.
Should we try to read it from top?
I just finished skimming it. That's why I'm talking now.
Yes, that's also good.
It took me a good like 10 minutes to skim it.
Are you talking, Victor, by the way?
I can't hear Victor. I see the green light on, but I don't see Victor talking.
Yeah, I also see green light, but I don't hear talking as well. Yeah, and he's showing stuff, so let's ping him.
Let's ping him. Yeah, you ping him first. Say that we can't hear you. This is worse than glitching. This is like we don't hear him at all.
Yeah. The internet before seemed more stable. Maybe it would be better to reconnect to it.
Didn't
Looks
Victor
like he
have his
doesn't see it in
friend
chat.
that also runs the recording? Couldn't he run the mic?
Wait, I'm gonna check the YouTube if even there
Is
it's.
he talking on the YouTube?
Let's see. No. Also not talking on YouTube. Oh, now he sees.
Oh yeah, he sees now. Let's go. Could he hear us, or he can't hear us because like we had to ping him, so I don't think he hears us.
Okay.
Hello.
Out now?
Yes, now we can hear you.
Okay, I'm
Yes,
very annoyed at Discord today, then. But
So, yeah, you talked and just we saw the green stuff around your profile pic, but no like sound. That was weird.
okay, it doesn't matter. I probably was not at this point. I was not saying anything super interesting, but yeah, I'm really annoyed that if I just stop hearing me again, just message me again, and maybe I can close it. At least the recording is this is at least I'm liking the thing with the Streambox thing that Alex did more now because it's still recording even if my internet is dying because it's on an Oracle Cloud machine. But
That's
yeah.
a great idea, though. The Oracle Cloud, like a different device for recording than just the.
Yeah. That's the. I think until now I was not liking it that much because it was causing more problems with the thing that it helped. But today is saving the day for the recording at least. So.
Yeah, I remember I saw the recordings get like 49, like 50 views. So I assume there's a lot more people watching it after.
Anyway, so yeah, I mean it's. I guess it's not. I should use the streamers and should. Okay. I think. Yeah, Alex is telling me. I think he's right that maybe I should close the stream box, and let it record, and maybe Burnie can join it because he should start fastest, and close it later, and then I can use all of my internet to talk because I otherwise consume my internet and it's kind of dying now. But yeah. Anyway, or I'll
Yep, there's
just.
nothing to glitch again.
Okay. Well, the recording seems to be working anyway, so I'll just leave it here and trust it and close it for a bit. But it's not recording the screen now. It's annoying. I don't know if I should fix it or.
I wonder if this is just Discord issue since you have it on both internets. Maybe if you
Yeah,
would just restart
maybe
Discord.
At the same time.
If you could test if it's a Discord issue by having Alex join, and if Alex is not having the problems, that shows it's a Discord issue. If you're both having problems, that might show it's a internet issue.
Yeah.
Or just trying to restart operating system fully. Maybe could fix it.
Yeah, maybe. I could try talking on phone, but then I can't. Then I can't share the screen. I don't think the screen is being recorded anyway right now, but yeah.
Could somebody else share the screen like Bernie? Or is it only your account that gets screen share?
Oh no, you can share the screen. It's just the recording is just the unuser recording things. Also, Bernie should be able to access the recording thing, but I don't know if you want to figure that out right now. I fix things if
I think I have the link. If so, that's true.
Yeah, but I don't know.
Oh yeah, you have
maybe,
the perm.
but now we can hear you well again, so that's good.
Yes.
Okay.
I'd rather hear you
Let's try.
talk than see the recording.
Yeah, I just don't know if I I want to open the recording thing because it will also be taking my internet or whatever for the connection, and maybe I should just. I probably should close everything except the Discord too, in case it is my internet, but I don't know. Okay,
They use a
should be on,
2-layer, right?
okay. It should be
They looked at
recording
2, I think. Yeah.
should be recording the screen now. I'll close the YouTube also because that's probably taking my internet, and hope someone will tell me if it breaks. Yeah, and I have I have too much Firefox windows open, so maybe that's also my fault. But I don't think, yeah, it shouldn't. Even if you have that much, it shouldn't be that much of a problem because it's old. Okay. So what was I saying? Yeah, I don't know. Let's go to the start for a moment and actually quickly skim the thing instead of doing the thing I was doing, where we were kind of jump to different places, even though it's interesting. Wait, yeah, this is just the typical introduction thing. Okay. Yeah, this is the big typical talking about the origins of the field, whatever people don't know about it. The GPT study found evidence that the copy suppression constitutes a self-repeated phenomenon. I think it's less interesting if you have something you found in GPT-2 and find it on a tiny model. I think it would be more interesting the other way around. But maybe
Yeah, the other way around.
One.
I feel like the other way around is a lot more interesting. That is true. I feel like they could have just looked at GPT-2 and done this. Like, what was the point of going to toy model? I guess maybe to make it easier to measure.
Yeah, it's
Like,
just easier.
Yeah, it takes less compute to look at this. Is that the only reason why?
It's
That's the only
not
reason.
just the compute. It's just I think you can realistically figure out completely how the toy model works, and you can't do that with GPT-2. Or maybe you can figure out how a tiny bit of GPT-2 works at those you think you care about. But even that's harder because there is a lot of layers to look at and all that. While when a one layer model, the good thing it has, it might turn out to not actually generalize with then it sucks. But
Oh, you started
the
glitching again. No, we can hear you. You just sound distorted. We have a distorted effect. That's it.
Okay, I'll say it anyway then. So
no, we can hear you saying, but like it sounds like you're like lengthening the words with glitch effect. That's around it.
Okay, I'll anyway. So what was I saying?
Now it's good again.
Kind of. Okay. Well, I don't remember what it was. Yeah, the thing about the one layer models is you can just look at the entire attention patterns, and because there is like one, or if you have a few heads, have at least like at most like 4 or something like that, and you can't just understand it fully and look at the MLPs and do things with the layers and have a pretty good idea of how everything flows. And I think that there is a reason why there is a few papers where they reverse engineer a tiny model and people haven't actually reverse engineered GPT-2 yet.
Yeah.
So it's just
I'm a
much
little-
easier. That's the thing. But I do think it might turn out to not be actually useful. And turns out that models are GPT to do different things, very different things. And I have some
Yeah.
reasons to. But at the same time, I think the modular multiplication thing from Niel did lead to people figuring things out in GPT.
Yeah, I'm looking at like this research. I honestly don't think it's anything like I feel like the idea like showing it could work on toy models is good, but I don't think this is like a lot. Like it doesn't it has more to answer. It feels like it didn't answer a lot. It just
I
made
don't know.
a
I feel
methodology.
like but I would like if there was a lot of people like it's kind of relatively easy. I feel like people with not a lot of experience could try doing this and figure something out. So it would be nice if we had a lot of examples of people of like how tiny models work because
Yeah.
at this point it's not like we know how like you could research GPT-2, right? But it's not like we know how GPT-2 works. So at least if it turns out if it's easier, you might figure out have a lot of people doing tiny papers where they figure out how some tiny model does a specific thing, and then we mainly learn some primitives or like some small mechanisms that you see similar stuff on bigger models just composed with other stuff. I can see why this kind of thing, uh, especially if you are like thinking like Neil about the pragmatic interp thing stuff, you might think this is too slow or something, or like it won't generalize. It's
I
possible
don't
the
think
bigger
this will
models just
fix.
learn. Yeah.
Yeah, I feel like currently this won't help a lot with actually solving the problem. This is just like, oh, the sky is this color. This is like that. Like it showed the color of the sky, but didn't do anything.
But I mean, if you find, I don't know this paper, but the thing you understand a lot of tiny models, maybe you learn something about, okay, the models represent things on this way, and you learn something about how representations could work that lets you, I don't know, embed better sparse encoders or something.
Mhm.
Like
I'm
you
curious.
find some way models are representing some feature in weird non-linear way, and you think of looking for that weird non-linear way on bigger models.
I'm a little.
Like not saying this paper shows that, but I mean on the whole thing of people looking at one layer transformers that maybe there are some interesting things there. I don't know.
I'm also.
I feel like it could also be that it's just useless.
I'm a little curious, like when you talked about little models to like generalize the bigger models. I'm curious if people actually tried like getting a behavior in a small model and then like literally like patching the instead of the activation, like patching the weights of the heads into the other model onto
Oh,
like
you
a
mean
clean model that's
patching
not.
the way? But I mean the problem is that wouldn't work because the other model, like if you train it a bit after that, maybe, but like the bigger model won't like know what to do with that, right?
Yeah.
Like it's going to be a completely different. I could imagine a thing where you patch the weight thing on some part of the bigger model and then train the bigger model a bit, and maybe it learns to use the thing you understand in some way. That actually
Yes.
could be a
So
cool research.
yeah. So like this made me think of an idea of like we fine tune smaller model like to do some random task A. You patch in the parts that does task A onto bigger model, and then you train it a
Or
little bit to
like,
see if the model is able to
for
like.
example, you could patch the modular addition models into a bigger model and see if they.
Yeah,
but yeah, I think you will have to train the bigger model a bit afterwards.
Yeah,
to
but
see
like,
if it
but I'm
catches it.
saying like this would be interesting to see if the model is able to like just accept new parts of it.
Yeah, I do think you will need like to train it to a bit to do that, but yeah.
No, that was just that was a random
if
idea I
you're
came up
doing
with.
that, you might as well. It might it might be worse in a bunch of ways, but maybe you can
But
also try
mhm.
writing an algorithm. Like you can write code and turn it into a model with a tracer. It's like a Google thing where you can compile things into code into a transformer. So you could also do that manually, like manually do some mechanism that does a thing and then train a model.
Yeah, but like I'm curious if like we know like we could like steer a model to be like similar to the fine-tuned model. Maybe you could like steer it with instead of steering it, you just like inject the fine-tuning from a smaller model.
I mean, I feel like it's kind of hard for that to work because the when you steer it, you are taking activations from the same model.
Yeah.
Like the tiny model can be representing a completely different way, right? Uh, and so it's hard for it.
Like I mean, like the tiny model is like a distilled version of the bigger model, like a distill of the bigger model.
But even then, if it's trained, yeah, if it's a Steam version, they should expect it like the directions to be different, even if it's
If you're able to use distilling to unlearn, maybe you could like do the reverse, like unlearn on the distilled model and then put it into like the bigger model.
maybe
No. I'm just like I'm just thinking of toy models, just thinking of possibilities.
yeah, it's kind of. I don't know if that would actually.
Yeah, I don't think it's practical. I'm just spitballing ideas because like this is.
Yeah,
like,
no. I feel like there's something like that could work, but you need some extra steps. Like
yeah, but if getting that to work, it could show that could literally show proof that smaller models can generalize to the bigger one.
I guess.
In some way.
Anyway, going back to the actual paper because I feel like we are not. Yeah, let's. What are you splitting copies? Okay, so yeah, what do they? What are the problems? The pressure recognize person. Cover splitting. Mechanism summarize the main conclusions below. Okay, so they say the main conclusions. They have two stages, which is the vocabulary splitting. The model split the numbers in the list into non-overlapping split in some hands. This process represents a simple solution. Shining and persists even and weight guides. So the numbers may have been based towards simple solutions. Yeah, I do think neural networks have inherent bias towards simple solutions anyway. But yeah, that's a nice thing, evidence of it. Copies of pressures. Models develop copying heads that copy for tokens as part of the solutions. So wait, so is the thing so is a task they have a list of numbers and then just the model outputs the okay I can see it here. Okay, depends. Okay, so you just give it some number and then you give it the some separator token and then the list and that's it. Okay. I wouldn't be surprised. I expect before reading the paper that the model uses the separator token to store a bunch of things and do stuff. Well, not because it's a one layer. No, yeah, it probably uses the. Yeah, we have a one layer model, no. But if it had more layers, I expect it will just store a lot of intermediate things on the separator token. Because it's where it can see all, the entire list. Or like, if color splitting. Yeah. So split the numbers in the list into non-overlapping legends between attention heads. Not sure what that means yet, but okay.
I think before this there's a good section above it. If you go a bit more up top. Yeah, when it starts, the model was originally proposed. I think this is a good thing to read first.
Okay. Where exactly?
The model was originally proposed.
Here. Interpreted. Okay, so. Find a solution found in translating output.
So this is actually building on some previous paper, it looks like.
Okay, let me. Okay, so
Yep.
they yeah. So this paper was for a challenge thing.
Oh yeah, another circle.
Oh yeah, that's another thing. Yeah, that's another thing. I think this kind of thing can be useful of like the seeing learning this kind of thing about the models learned to use circles or whatever from tiny models can help with bigger models.
Yeah.
Yeah. Moderations of curious, like if there are more. Yeah, here there is a best submissions. I wonder if this is not. Is this the thing? Oh, wait, yeah. This is not the one that I consider the best submission. So I wonder what the best submission did. And I think it's interesting if there is a bunch of different people looking at the same model and there is like more than one paper or post about it.
Yeah.
I don't have the. Okay, I'll look at that later. Yeah, that's nice. So small attention. I usually try to not to ignore the introduction part because it's kind of useless most of the time. But you're right, that was a good thing to read.
Yeah.
Oh yeah, one part where the introduction was very useful was the RMU paper, since the unlearning rate and the number of epochs you needed to unlearn were very specific. I did a low amount in low learning rate, unlearning rate, so I didn't unlearn.
Circuit acts as a copy circuit. Okay, there's a sprinter thing here. Oh, there is another.
Yeah, it's the first one actually. Oh, copy expression.
Okay, so this is in this copy consensus, but in GPT-2. Okay. But this is okay. So they did. Okay, so they did put here October solutions. Okay. So this thing, they here figure out how the model works, and I think here they're trying. Also, they talk about the stuff we were talking about. Okay, I guess I should just read the whole introduction first.
I think Victor is talking again. Are you?
I don't see the
Without
green
muting?
though. I don't see him talking.
Vedic, yeah, you're asking Lone Wolf. Yeah, let's ping Victor as well. We don't
Oh, I
hear
am
you
seeing
now.
your question, Lone Wolf, for resources on regularization.
Yeah, Vedic is used often in LM training as a regularization technique for criminal recruiting. Now we can hear you.
Okay.
We heard R.
Yeah. So I
Yes.
was in the you were just reading this part. I hope next week it works. Discord works again. It's just kind of annoying. But yeah, sorry for all of the problems today. But I don't know what else to do to fix them because I already.
I
I
wonder
mean, I
if
guess
you
it was.
restarted. I wonder if you restarted Discord or operating system, if that would magically fix it.
I'll try at
Like,
least. I prefer not to restart the operating system right now because it will take longer and all that. But let me restart Discord to see if it works better.
okay.
That at least. So then.
Yeah, VDK is like adding penalty proportional to the sum of the squared weights to the loss function. So like it incentivizes the weights to not go haywire, basically.
Does it work well now or?
Yeah, now we can hear you. So let's see if it's stable.
Okay. I think it's already on yellow the connection, so also yeah, let me also try going back to my other internet because this one has not been working well. And maybe the original one was a bit better if it was not working originally. Okay. Let's try you can hear me right now, no?
Yes.
Okay, let's me just stay here, even if it's probably not. Okay, let's try and see what happens. It's not going to. Yeah, it's not going to be recording the screen. Okay, now it's recording the screen. Ah, ¿qué quiere decir con eso? More attention. Okay. Okay, so the OV circuit as a copying circuit is copying for number of tokens that present in context which result in higher number of tokens that present in context, higher values on the diagonal of the OV matrix as opposed to off diagonal matrix. Ajá. Further, bring attention to the smallest number token in the context, larger than the current number token that was given as input. I don't understand that yet, but okay. Since the context consists of a sorted list and its corresponding sorted list up to including the current number, the attended number token will destroy this number token in a sorted list as the current number token. While you set the sorting process in figure 1. Ajá.
Hmm.
Okay. Okay, this is a natural question arises, which is also what we were asking. So yeah, they are predicting what we were asking. So, why such studies simplify model when state-of-the-art system or the monitor is more complex? A compelling hypothesis that offers a potential way forward is the universality hypothesis or convergent learning hypothesis. This hypothesis suggests that certain fundamental patterns of how neural networks organize information occurs across different scale architectures. Just by installing simple models against to understand principles that apply to more complex life forms, studying simple neural networks might reveal things that suggest to larger models. Kind of. Yeah, I think that makes sense.
Sometimes.
I'm not sure. I feel like, for example, Neil had made a paper about this that he doesn't like as much anymore. But I'm not. Are you still hearing me? Because it says I'm.
Yeah, we can hear you.
Okay. Yeah, I am because it. The Discord thing says disconnected sometimes, but that doesn't correspond to where you are not hearing me, which is annoying. And like sometimes you are not hearing me. I just and it says connected or something, but it's. It keeps making the
Now it
Discord
seems
connected and disconnected noises, which is annoying. But anyway, uh,
I also
we-
have high MS. This might be some global Discord thing, actually.
oh yeah,
No,
probably. The thing is,
but I also
the
have very good
recording
internet
seems to
right
be
now, so
working well. Although I think the recording, like the virtual machine, is probably much closer to the Discord servers. Like it should be on the same Discord server as my like I spent the Discord servers I'm using and on Madrid or something, and that's also where the Oracle machine is. I guess mine could be in a different place or something. But yeah, the thing that the Oracle machine is also in Spain, so it's also should be getting the same Discord connection. But maybe just like since it's probably on the same city, or maybe it's even on the on the same data centers if they're using Oracle Cloud or whatever, or even if they are not, they're maybe closer.
Mm.
So maybe that's better. But
but
yeah,
now it seems stable, so looks hopefully good. So hopefully it will stay stable now.
yeah. Yeah, like the down detector thing says there is a bit more that like it doesn't
Yeah, I
seem.
just checked that right now as well. It seemed fine.
Anyway, I should just keep reading, and I spend more time, worrying about that than actually reading the thing. So,
Yeah.
the university hypothesis provides a framework to investigate from integrals. What will drive the development in the server's internet structure? Also, maybe if some other day I have even worse problem, I can't do it at all. Maybe you can try reading yourself the paper and streaming since you also have access to the thing. No.
That's also
But
an
if you don't
option.
want to, it's okay. Okay.
Today I'm slightly tired, but some other day possibly.
Yeah. Is it primarily the training data, the model architecture, or specific training parameters? Yeah. Yeah, I think in
Who are the
general, I think if it does generalizes, there's a lot of nice things about training on small models. That like you, for example, you can't train a lot of GPT-2s, but you can train a lot of different small models with different learning rates and things like that. I'll check, how the learning rate affects the thing, which you can't really do in GPT-2. Well, now in GPT-2, maybe you can have a lot of compute and train a lot of different GPT-2 size models, maybe. But yeah, no. There's
Yeah.
probably some smallish size of language model you could try training yourself in a decent GPU these days with like the better algorithms without half and whatever. But still,
By the way, one thing I'm now trying with this paper is like giving it to Claude, saying to Claude like extract all definitions of the different circuits that were found, and then asking Claude like to plug in a concrete example. Uh, uh, yeah, like I'm doing that with math generally in basically all AI papers. Like
yeah, we need. I probably
extract the
will be.
equation.
I would
Yeah.
be doing that if I had more. I have the more expensive cloth the subscription because I feel like I have the $20 one, but I feel like I have to not do everything I want to because I run out of cloud usage very quickly.
You can also enable like extra usage for a few dollars, but yeah, I
I
see what you mean.
tried that. I ran out of the few dollars I put in so fast. Don't want to try anymore.
Yeah, it's
To
too
be fair,
addictive.
I was also trying the thing where I was, getting Claude to write a few lines of code for a for a notebook into the for also a similar thing like this, like taking a one layer transformer and try to reverse engineering. I was doing a lot of code and copy pasting the code, running it, then putting it, copy pasting it to Cloud and maybe saying a bit about how I thought it should continue or whatever and what it was missing. Yeah, so I did like 130 like the last week, like 130 like cells for a few lines of code in in a Jupyter notebook. So that's probably not. Yeah, it's kind of a lot. So it does make sense. I was running out of it, but still.
Mm,
I feel like I only
Jupyter notebook in
like a
context.
few conversations. But anyway, I should go back to the paper instead of talking about this.
Yeah,
It's already kind of been going for a lot, and people
like
are probably
yeah. Or I also sent like the what I did basically with Claude, with trying to plug in concrete
see there is a
example.
lot more people now. Uh, Anyways, feel free to just say something or interrupt them at some point and talk about something you want about the paper. Uh, Especially today that I not that I'm having a lot of problems with Discord and not able to take talk times.
Now it seems stable for a long time, so that's pretty good. Sometimes
Yeah.
a little bit glitch out, but that's like for like 3 seconds and then it goes back to normal. So
Okay.
that's
Going
now
back
it's
to
like
the
stable.
paper anyway. Yeah.
Yes.
So they are saying the thing we were talking about, that that you can with a toy model you can do a lot of nice things of like trying a lot of different things and seeing what actually matters, which you can't really do with GPT-2 because you can't train a lot of GPT-2 with different learning rates or whatever. At least with a reasonable amount of compute as a academic instead of a big lab. Uh,
Maybe we can get sponsored by some big lab.
Maybe.
But yeah.
Development of developers, the biggest parameter. I mean, that's what they, or like, I think at Luther, what they mostly do is being sponsored by, like, cloud compute things because they get the Luther AI to test them and like also do publicity for them basically because they know that if the Luther AI people use it, like that will spread maybe to other open source stuff.
Hmm.
So I
That's
think
one
like
way.
I know that I think they also got money from the government, from the U.S. government too, at some point. I don't know that much about that, but I think there was something like that.
That works as well.
But I think Luther is also like, you know, uh, one of the organizations who publish more, with more citations or something. So they are some big old liars. So you should probably not expect to be a Luther, basically. Anyway, probability. Yeah, I think this is nice. I think there is not a lot of papers looking at looking at how reverse engineering type models are looking at how they develop. Which is also another thing that we were talking about. Maybe this doesn't generalize for bigger models, but you can't really do this for GPT for most open source models because we don't have like all of the. Maybe for GPT-2 you could train a GPT-2 size model. Like you could use the GPT-J and all the Luther models that have a lot of Pythia or whatever. I think with Pythia you can get all of the
Yeah, those are
checkpoints.
small enough.
Yeah,
Yeah.
but no, I mean more of like having all of the checkpoints
Mm.
where as they were trained, right?
Yes. Also, Allen AI or the people behind Olmo, they also release checkpoints. I'm not sure how
Yeah.
many of them though.
But
Those are the only two I know of, like Elutra
for
AI and
them,
Allen AI.
yeah, but
That's
all
like
of the
fully
big,
open source.
even all of the other big open source models, open source in quotes, are not really open source in they are open weights. They are not even open source in the training code,
Yeah.
and they are not
Yeah.
giving you the all of the
Yeah.
checkpoints. So
And
you can't
yeah.
really do this kind of thing.
The only that I know that are fully open source are the old like Elutra AI PTA models and the Olmo models. Do you know the Olmo models, by the way?
No, I didn't know, but that's nice. Maybe you can like
Okay.
link something to them on the chat or something for in case other
It's
people also
yeah. Those are actually, and they have relative like they have reasoning model that's fully open source basically. All the training data, all the training code, multiple checkpoints as far if I remember correctly, and so on. So I'm surprised this is not used in Mech Interp more actually because it has everything
Yeah,
basically.
I feel like there is not even with the PC models. I don't know if there is. Maybe you can find a paper and we can read it at some other point. Like if you find this one, that a paper where they do this kind of developmental inter where you have a graph. I mean, something where there is a graph like this where they found out how some circuit develop, but in GPT-2, right? I think it's a bit
Yeah,
harder
yeah.
because maybe you are looking for it on a place and you don't really completely fully understand GPT-2 anyway. So uh, you might see that might even think that there was a thing. I just switched places and it was on a different head and now it's on this one or whatever, and you just don't know because you were only looking at the thing you found. I don't know. It
Like
is harder,
that.
but it will be nice if there is some interest research you can do of this kind of, looking at the Pythian models or whatever and see how they
I
change
mean,
over time. There's probably some papers. Sorry.
there was something we looked at some months, maybe months ago at this point.
Oh,
Was
maybe.
the interpreting in time, where they were like first phase is the statistical features. I mean, just statistics formation, and then the next phases are
Was that
feature learning.
not? What model were they looking at though? Were they just
I
doing a
think
toy
one of them
model
was
or?
No, I think one of those it was LLM, and one of them I think was PTA.
Oh, that makes sense. Oh yeah, but then they probably were doing it in Wikipedia because that's the one where you have uh,
Yeah,
the thing. Okay, so it does exist. I think it would be nice to see more of that kind of research.
yeah.
But a bottleneck for it is that we don't have that many models that are that have all of the checkpoints, and the PC ones are probably already old. I don't know if Luther is probably making bigger, newer ones, but still. I like the one that you mentioned. If they do have like also the same thing, but also for reasoning models, it will be interesting to see if you have like the same model as a reasoning. You can also do that without this, but if you have the model as it, first on the base training and then on the reasoning training, you can see how it. Maybe you can learn something interesting about how it changes.
Yeah.
Yeah.
It was some Chinese paper. I cannot find it. I think we went
Okay.
through it here, but I really want to find it back.
It's like there's a lot of research to be done, and just
Yeah,
not
for
enough
sure.
people. And
Yes.
until we actually understand which models. Maybe in the future we just have Cloth 5 or whatever do the research for us, and it will be
Like I
faster.
wouldn't. Yeah. Like
Or
I
parts
looked
of the
some
research for it at least.
like right now some people in Hugging Face they do like hundreds of GRPO experiments using Claude Code with skills that ground it a lot. So I wouldn't be surprised this isn't far away actually.
Anyway, going back to the thing. Okay, let's ocular videos. Yeah, let's go back to the papers for a moment.
Yeah.
So
We're drifting
the
again.
if I understand correctly, so basically, if I understand correctly, this paper, this other thing had already like this other group has already figured out how the model works. And the interesting new thing this paper does is they look at the developmental interp version where they just take different checkpoints and see how the mechanism that the other people found out actually works. And the reason they don't try different a lot of things like the thing that Lambert was saying about different learning rates or whatever is that they were using a model that was already trained by the other people. Maybe they were using the same model. Like
Yes, I found it.
but they were
Evolution of
at least
concepts
using the
in
same
language
setup,
pre-training. Okay.
and they probably they then figure out how it develops, which is nice. So okay, so there is peculiar splitting copy suppressions.
Yes.
Development of response. So two forms of head specialization, pattern splitting. So models split the number of lists into no-overlapping regions between attention heads. Uh-huh. The vocabulary into no-overlapping regions between heads. I don't really understand that, but okay. A simple solution compared to having multiple heads handle overlapping ranges. No overlapping.
Maybe right now it's good to go where they talk about baseline model setup and training because I'm now a bit
Yeah.
confused by the input.
Okay, let's continue. Oh, the input,
maybe-
the input, I think I do understand it. So the input is just this. The input is just and under the list, then some separator, and then the model has to output this, which is the order list.
Okay, I see now. All right, so it's like auto regression like this. Okay, that makes sense.
Yeah,
And
and
what
it
is a
just
separator really?
Hmm?
What is a separator in this context?
it's just
That's
some
just a token.
Yeah.
Yeah.
Okay.
It's just a vocabulary part of the tokenizer
Yeah.
that then
Alright.
transforms it into some vector
Something
embedding.
to remember in this kind of thing is
Embedding,
that
yeah.
for the model, all of the numbers don't have an inherent meaning. For the model at the start, when you start training, it's just we're simple 1, we're simple 2, we're simple 3, and then another we're simple and so on, right? And then it has to learn that
Yeah.
this symbol means 8 and this symbol means 3 or whatever to do the algorithm. Or at least,
And
learn some algorithm. I don't want to say this tiny model really learns what the numbers mean. It's more like they learn some tiny algorithm that uses the number correctly or whatever.
yeah.
Or something like that. Where the thing that a big transformer, a big language model learns when it learns about the
Like
numbers and math or whatever, it's probably closer to what we mean by learning what the numbers mean. But yeah.
my question would be if like if the input is like to the transformer is just the first 3 and the output is just the last 3 instead of this next token autoregression, if that would also lead to some circuits like this, or if the autoregression is important token by token.
Oh, you mean okay? So you mean you input this and you output this, right?
Yeah, and you don't even need a separator there. Yeah.
Or like, how do you output the three things? How do you output the order list though? So do you mean without regression just input is this and output is this? Yeah, I think that will
Yes.
probably work differently. Yeah, because
I'm
the
curious how
way
differently.
like I think this whole mechanism it works because like it makes sense because of the auto-regression, if I'm not mistaken.
Yeah.
You will try it, but maybe there's a thing
That
that
should be
once
interesting.
that you could try get ask Claude Code to do.
Yeah.
But there's probably code for this paper. I don't know, but I will. Yeah, if there is, you can just
Hopefully.
give it the code and say, "Do this," but with the with a non-autoregressive model, and maybe it can figure it out.
Yep.
I expect at least that you can just train. It seems like it will be too hard to remove the autoregression and just train it and then plot the same things. And I expect the plots will look very kind of different. Like this actual model, this model, if I understand correctly, does use the autoregression to do a thing. Like where it uses the fact that each model is makes each model pay attention to the other models to see where they are on the list or something like that.
Yeah.
And that doesn't
It
work
looks
if it's
back.
not autoregressive. So it has to learn a different thing. So
That
yeah.
will be interesting, I think. Yeah.
Like
Maybe.
also the model in my paper where I was also it's kind of very similar to this one because it was not a list, so it was also a list of numbers, but they were positions on a graph, and I have like on the first list was like how they were connected, and it has to output the path to some number, right? And to do that, it did a thing that was probably depending on the autoregression because it was using, paying attention for each number to the previous numbers, and sometimes like I have separator things between each of them, and it was using the separator tokens to do intermediate computations.
Makes
So
sense.
yeah.
I've seen that. Neil talk about it in some video. It would light up in my mind. Okay. Yeah.
Oh yeah, there's other examples, but yeah, maybe it was an example. We for some random reason decided to put commas as a outal token. Here I don't think they do that, and the model just learned that
Okay.
okay, so that when the list was in the worst
Wait.
order possible, where the
So
numbers
the
were backwards and it couldn't auto-regressively uh, pay attention from future ones on the line to previous ones. It just used the thing. It doesn't seem it does this here, but that's also because it gets to do it like from here to
wait.
the things.
Are the separators I'm not sure how it's called in English. The symbol after 8, the comma, is the
They
comma
are not
also
here, I
tokenized?
think, because here it says 3. There
Oh,
is
okay.
5, 3, 8.
Then
So I
I'm
don't
a
think
bit
so.
then I'm a bit confused why there is no comma after 5. But maybe that's just like mistake and there
Yeah, I
should
think
be
that's a
comma.
mistake. Yeah.
Okay, because yeah.
On
Also,
my
I'm a bit
paper, we did
confused. Like,
tokenize them, and I think that actually changed the. I wouldn't have done it again because I think that actually changed the algorithm a lot.
yeah, like okay. One thing I'm kind of confused about though is that they replace the separator with the first one. Like, you know, in the example, there's shouldn't the 3.358 shouldn't it be like at the end after the separator if they do autoregression? Why it instead transforms into
No. Here the separator outputs 3, right?
okay, yes.
Because yeah, they output the next one, so the separator outputs 3, and then 3 outputs. I don't know why it's not. It's nothing here, but
Copy suppression maybe trying to show. I don't know. Okay.
oh yeah. Eh,
Hmm.
It should look
Okay,
fine.
so I see now. Okay, I see now. The output field is different from the input field. Okay.
Yeah, that's how autoregressive models work, right? They just on each token you predict the next one.
Yes.
Also, another thing is
More
okay.
like
So my paper was a 5-layer model, and I feel like there are some things that happen on more than one layer that don't happen in one layer. And maybe looking at 1-layer models is not as good, and you should probably look at 2-layer models, because then the model gets to do attention after an MLP.
I feel like a way to prove that one layer models are bad is maybe proving that certain types of heads can't form in one layer models. Like maybe induction heads can't form in one layer models or anything similar.
I mean, and induction sense can form 1-layer models, though. So
But like I'm saying, like just try finding an example of a head that only works in
I
multiple
mean,
layer
they
models.
also doing 1-layer attention only model, I think, which says already it's only technically Turing complete. So yeah, I think there is some ways it doesn't generalize, but I don't think they are obviously bad in
okay.
that you might learn some interesting things from them that about how attention patterns work or whatever, how they develop. But yeah, or about gradient descent itself. But yeah, I feel like I keep repeating that I just should talk more about the actual things because I don't think I'm getting nowhere. I'm just saying, I don't know, it might generalize or it might not. I think that I already made that point that it's not. Stream size of 96. Yeah. I wonder why they pick like 52 tokens instead of, some round number. But okay.
Fifth vocabulary size, 52 tokens. Is it like all the numbers from 0 to 5 plus
0
set?
to 50.
50, yes.
I don't. Yeah, that's including 0 and the separator. I don't know
Oh,
why
yeah, it's including 0, right?
Okay,
Makes sense.
yeah. I don't know why they did that. They did 15 tiers of 100 or something, but okay, that 50 is okay, I guess.
Let's make a more general model. That's okay. So two paper ideas, variable length and variable and even like bigger numbers.
Or just more layers and see what happens.
Yeah.
But yeah, I feel
Instead of
like
a
that's
more
the kind of
layers
thing that's
approach,
probably not that worth doing
I feel like
until
instead of a
Claude
more
can
layers
automate
approach,
it.
I feel like a method I'd probably do is probably like try seeing if like patching the model from smaller to bigger, do the reverse of distillation.
maybe also like
I think maybe you should
wouldn't
instead
more
focus on
layers.
more bigger models and this kind of thing is. I think this kind of thing is nice for new researchers to like get into Mech Interp doing this kind of learning a tiny model, but also maybe soon Claude will be able to do this kind of thing very easily. So maybe we just need to wait a bit for Claude to be able to automate it, and then just spend some weeks having Claude make like a ton of different tiny, put them on less brown or something like tiny reverse engineering of thing. I will be worried of making sure that it actually makes sense and you are not producing a slop that doesn't that only looks like you're reverse engineering. But I think this kind of
That's
tiny
important.
model research has the advantage. You can easily do that in that you can run a lot of more plots. You can just ask Plot to plot a lot more things, and if you were wrong, it will stop making the correct results. Right? You can just
Yeah.
you can be like to Claude, are you sure? And get it to make a lot of different. To keep checking, and even if it thought it was right and it was wrong, it eventually figures out because you get a lot more data on the model. It's not like a bigger thing where you get a few experiments and have to interpret them, and that's even harder for humans. That's a big problem with science. It's more a thing where you have insane amounts of feedback and a very short feedback loops from the model. So yeah. Oh, you're still
Yeah.
hearing me, right? Because now Discord is showing like
Yeah, we can hear
lower.
you.
Okay, it's on
Yeah,
yellow.
you're
which-
just yes, you're just slightly glitching, but understandable. Usually you go back to normal in like 5 seconds, so it's fine.
Okay. Stop
Yeah, you're
worrying
back now
about that
into
for a
normal.
bit.
Yes, it's good
Okay.
now. It's stable. That's good.
Let's try. Okay. Transform architecture and it is based on the sorted circuit based on similar figure. Various circuit copies, sort tokens in the context where the circuits tend to more smaller numbers larger than the current token. Okay. Yeah, that's the thing we were talking about. Layer norm with the case set to yeah. Architecture model 30 parameters presented with the K, but they didn't change the learning rate as but they did change other things. They can't think of changing everything though. I think it's more pictures on the training data, list length, vocabulary size, or manipulate training data. In the latter, we find most impact of varied training data can be boiled down to changes in distribution of the separation between list elements and the training data set. For example, oh, that's nice. Yeah, I like this. I feel like they did very well for this kind of tiny model research where they actually found like a lot of interesting things about how I think there's a lot of papers that like where they research how changing things about the architecture change things about the actual model, right?
Yeah.
And it seems like it shouldn't be that hard, but they not. It is hard in some sense. There's not a lot of people doing it. There's also not a lot of people with tiny models. I think that's the strength of doing things with tiny models, that you can do this kind of thing. Or like very quickly iterate everything about how the model works and see how it changes the thing, right?
Yeah.
Dataset with a list length different from 10 indicates this is a superscript. That's just that this is generated when from sampling as described in the beginning of the session with the give me the superscript for the foul list length. They already had a lot of the paper ideas we could have, and they did. So they changed
Oh, way very less
They
time.
also they also
Oh no.
they already did the vocabulary size thing that we were talking about.
Oh no. Okay. 2
You can
steps
have
ahead.
other ideas. I think it's nice that they already did it.
Yeah,
So they
yeah.
changed
Actually,
the
that's good.
length, they changed the vocabulary size, they changed the lead distribution, meaning how separated
Oh, interesting.
the numbers are between each of them, because they found that matters. And they fixed the lower d values. Yeah.
Mean of
They
the
make
distribution, okay. And do they find differences in the circuits or?
Well, let's see. I guess they okay.
Hmm.
They have the data sets there, but I guess they'll talk later about that. This is just the setup part. Measuring development. So they study the evolution of attention heads. Yeah, I like in the paper so far. The head circuits have various measures. In this case, we describe this
Okay, like
content.
I'm not sure if Claude is hallucinating me or not, but like one thing I'm confused about, that the input is fixed. So it's when it's for instance predicting the last the last third token, it sees 2 previous correct tokens. I mean,
Yes.
the last number, it sees 2 previous correct numbers. So that way, it's like it's being given a hint.
Okay. I don't know. That could
That's
be. That's
but
not
maybe
what I was doing on my own paper when I was doing that toy task like that. I will just put the answer from the model in the
yeah,
output of the
right.
model.
That was my assumption. So
So are they doing that or is Claude hallucinating? Let's see.
I'm not
The
sure.
models.
I feel like they don't clarify, so both can be true. I feel like.
Maybe you can. If
What
they
did Claude
have
say was possibly
code.
the case? What did Claude say was possibly the case again?
Oh, that they output they use like they give the model the correct token here, like on 5 to predict it doesn't get to put his own guess and then it uses the wrong guess to get the next one and so on. It gets the correct one, which is a bit easier.
Yeah.
I don't know. I think can you ask Claude why it thinks that and where it is it on the thing? I find that
Yeah.
helps. And sometimes it tells me and I was wrong and it did say that, and sometimes it realizes you don't even need to tell it, it just realizes it was wrong itself.
Yeah. Like this would be so unusual, but I don't see it clarified. But yeah.
Otherwise, if they have code, you can copy paste the code and tell it to find.
Yes, I'm also trying to find the code and I cannot find it. Maybe if we would Google if we would email the people, they would just give it to us.
Well, it's not nice if they don't have the code. But yeah.
They didn't
I
share
don't
the code.
know. I don't know if this is.
Which section are you talking about? I want to go read the exact section you guys are talking about.
We are not talking about a session. We are talking about a thing that Claude said by being input the paper, and we don't know if it's true or not.
It could be a hallucination.
Yeah, it could be a hallucination. That's why we were talking about that. So Claude is claiming that here on
Okay.
this task.
Now Claude is like, yeah, oh yes, you're absolutely right to challenge this assumption. It's actually it can be both options, and I don't know, so it's in the same position like me right now.
Okay.
So yes,
I would
Claude
assume it's not
hallucinated.
happening. Yeah, but like the issue is it's not clarified in the paper, so I was like
I agree.
trying
At least
to
it's
ask
not obviously clarified on the paper. I
if I'm missing
think
something.
I would have done the other thing, but maybe not. I don't know.
What
Yeah,
was the thing you didn't
same.
do in your paper? What was the methodology you didn't do in your paper?
So the thing is, either you so your model from the separator outputs a 3 here, right? The question is, do you use and then you input the 3 and get it to output 5, right? The thing is, do you use the actual answer from the dataset, or do you use the output from the model? If you use the output from the model, like it's a bit different, and it can be harder if the model outputs the wrong thing, and then in the next step, it just keeps getting worse. Versus if the model, even if it gets it wrong on the first number, you can still get it on the
Okay, so you're saying there's two options. One for training on the input sequences. If you train on the input sequences and
The
it's
name of the
based on the
paper is on
answer.
the event and there is a link for it on the event on the
Yeah, I'll
reading group.
just give
What
it to
paper
him.
is this?
Okay.
No. I mean like for the concept of using the input indices to try training the model.
Claude calls it
Is it-
teacher forcing. And I never heard it before in this context.
I'm not
Maybe it's a
familiar. I'm
hallucination.
not familiar in general with this
I
type
heard
of
that
training.
before. Yeah, I don't know if it's exactly that, but I think it could be a thing. I think it's a thing in other contexts, not exactly this kind of toy task. But
Did you use the model generated output or use the correct output that was from the answer key?
yeah, that's the thing. So like you still answer, but I mean after since you do answer step by step, you could use like on the second step for the first one, you could use the correct answer key. So it only needs to guess the next one, and it doesn't matter if it already did the wrong one. But I don't know. They could have done either. We will have to look at the code. I think it makes more sense to not do the first thing. To not give it the answer. Even if that means it gets it wrong more often, because it will, put the wrong answer on the first one, and then it completely messes up the list. Where in the other way, maybe it gets it a bit better. I will also. I guess it depends on how. I guess it doesn't matter that much if the model is very accurate at sorting lists. But yeah, I don't know what's the accuracy.
Attended to number
Also,
token
let me turn out the
is
lights on
number.
my room for a moment.
Is it nighttime for your time zone or
Okay,
like
anyway, I
early
think
morning?
we spent
Is it
too
nighttime
much
or early
time
morning
worrying
for your
about
time
that,
zone?
and we are not going to figure it out from the paper, unfortunately. So let's just...
Probably emailing the authors is probably the best way to confirm your suspicion at this point.
Yeah, at that point, I don't care that much.
Invite
I
them to
will
the
just.
call.
I mean, if it would be nice to have the code in general. But yeah. Yeah, let's keep going. I feel like I've been going for a while, and I'm not. We are not going very fast today.
Okay.
Uh,
Yeah, let's assume it's how you normally do transformers and not this teacher forcing magic, whatever that is. Okay.
Yeah, let's let's keep going. In normalization, the model is trained with the way the case, and then they talk whatever. They talk about they say the hardware. They bring the result. They bring a bunch of things, and they measure development. Measure development. The output value and the query case circuits defined as this thing. Yeah, this is the okay.
Wow, the asking Claude for example of the circuit, it's so helpful. Yeah, you're now trying to find how QK circuit works. Yeah, okay.
I haven't
Determines the
used Claude
extent.
for understanding papers, so this is interesting for me. How you're just
I need to
prompting
try that
Claude.
more.
I don't do it. I don't trust.
expression.
I don't trust it enough. I don't trust it enough.
Yeah,
I think
like part of
you
me is
don't
not
need to
trusting it.
trust it. You can ask it where it figured out something, like to cite.
Yeah.
But I feel
I'm
like
probably gonna ask where it decided something, but like that's around the extent of it. I'm not gonna necessarily.
Yeah.
like the main use the main use case of plugging in concrete examples of the abstract concepts of the abstract math, etc., is I think like you often cannot go wrong there. Often.
I also noticing.
but
I
not
think
always.
Cloud Opus is much trustable than the previous ones. Like I find it making a lot less mistakes. But
Yeah.
yeah.
But still, it makes mistakes often.
Yeah.
Yeah.
We study a standard measure the validation loss when training. And when it makes tests, you sometimes can't tell it, are you sure? And sometimes it just figures out the correct thing.
Yeah. You're absolutely right to challenge that. Let me refund this.
ก็เหม็นกลินแสดง
Yeah.
เหมือนกันกินจิตใจ
Validation loss on
อาบแล้ว
I think you're not talking in English.
คิดเองหรือเปล่า
I think you have your mic unmuted and you're talking to someone not in English. Maybe. Or are you trying to talk to us?
Oh, that's another person.
Okay. Yeah,
No, that was
my
not
correct.
me. It was the.
Yeah, he muted himself, so I thought correct thing. Oh, and also left. Okay, interesting. Oh well.
Yeah. He also said it was late. Okay.
Okay, he's back. Okay.
Anyway, what we were saying. We study a standard measure to validation loss in training.
This is very good. Okay.
Model complexity. I mean, yeah, but it's okay to mention loss, but it would be nicer if they were looking at different, like the Mech Interp stuff. Let's say, okay, so they also look at learning coefficient. Mete brothers o local patient de los landscapes. Ajá. I have never heard of this measure, but it's nice. I guess.
What measure are you talking about? Are you talking about the delta, the gradient delta?
Local learning coefficient.
Yeah, I never heard about that. That kind of feels iffy.
Maybe it makes sense. From some other paper. Okay.
Well, considering the persons from like Timeus, they might like have a better understanding of how the learning rate works with it going to a more degenerate space, possibly. So maybe they change it when it goes to a more degenerate space.
Oh yeah.
Maybe there's because like Timeus does like look at like how model learning works. So maybe there's some reason for this.
Yeah, it's by the single learning people.
Yeah.
Yeah, so like this is so the learning rate probably has a reason.
I feel like a lot of the theory from the singular learning people doesn't actually explain other things about transformer.
I know that measure. I've been on a lecture by the SLT person, and he applied this measure himself to here. That's cool, actually. Wait, so what's the result?
I don't know. Oh yeah, anybody know what SLT is? Because every time I I haven't spent enough time to actually learn it.
Yeah, like.
Oh yeah, where do you hear about it? Oh yeah, was it in person or online?
In person on AI safety event. He gave a lecture.
Which AI safety?
In Prague. AI in Prague by Jan Kulveit and others here.
Oh, that's lucky.
I'm not sure how it's exactly. Human aligned AI event or something. Yeah, I'm not sure how it was called.
But, yes, I feel like they have a. This is cool. They use the SLT concept here.
And this is like measuring some like geometry, like algebraic. I think it's from algebraic geometry. To quantify generalization in some way. Yeah, measure of degeneracy of the landscape.
I mean, yeah, they are saying they are talking about the
oh my god,
estimated the brownness of the local basing on the lost landscape, which geometrically makes sense to me. I just don't know how much it makes sense to think about, simplicity of a thing based on that. Narrower basing are different, more complex model. Yeah, I guess maybe.
Yeah, they're talking about narrow bases.
Like,
yeah, they're talking about the narrow bases.
That a narrower version is a more complex model.
Yeah, I remember like something about like the more narrow basin and how it becomes more degenerate after like they go in.
I mean, yeah, if you are, seems like a more narrow basin will be like a more overfitting thing probably, but I don't know.
Yeah, like this is like one of the theories behind generalization in deep learning theory. Like the more flat local minima, the more generalization you have in a way, because you can go.
Yes.
But like,
I mean, it's kind of. I don't know. I feel like.
Yeah. Like it doesn't seem to be general rule. Like some paper is like flat minima also generalize. I mean, sharp minima also generalize. So I actually don't know. This is part of theory that I really want to go back for it.
Isn't that kind of the problem I have with this is isn't this kind of saying okay? So they find that the thing that the model actually learns has a flatter basing, So
Yeah, so it's more general, apparently.
yeah, but you should expect the thing that the gradient descent is actually fine to be on a bigger basin, right? Because it's more likely for it to end on a bigger basin than a smaller one. So
Yeah,
it seems kind of
that.
circular.
Okay, well, that's like one of the explanations why deep learning might generalize, because it
Oh
is
yeah, I mean
favorable.
you can do that, but at that point it's kind of saying it has lower learning coefficient. It's just saying, yeah, the model generalizes, right? I say it by if there is some circular thing going on where, I mean, yeah, it makes sense if the model, if you have this theory, and in theory, right, you're just saying the obvious thing that, of course, the model finds the broader basing and it generalizes because for the broader basing. But it's, I don't know how to explain, but it feels like kind of
I
circular in
think I
some way.
see what the mental move you're trying to make. Yeah.
But yeah, let's ignore that for a moment. So the thing I'm
That made me
interested
actually
in
happy.
is that's nice, but the thing I'm interested in is I feel like it's less interesting if they take all of these differences and they just look at the loss. It's nicer if they do some Mech Interp thing where they look at these graphs for different measures, for different
I
data sets,
yeah,
and see
like
the thing is the same.
the loss is good, since like I also read now recently a paper that's like the epiplex paper. I'm not sure if you saw it, which tries to formalize complexity, and they just look at the loss curves and try to
We
formalize
could
model
read it at
complexity
some
based
other
on
day,
that.
but yeah. No, I haven't, but
Yeah,
yeah. I haven't been reading
it's
a lot
very
of
good.
papers lately that aren't from on the reading group, I mean. So
Yeah, I co-read it in the Yannick Kilfer's paper discussion Discord, basically.
yeah, I should read more general machine learning papers that aren't just whatever it shows up on Twitter.
I mostly learn what is being like in those paper discussions, either here or in Yannick Kilfer's Discord, basically.
Yeah. I mean,
That's my two
yeah, I
sources
also
right now,
just mostly
mostly.
learn on this paper discussion. So
Yeah.
I guess I'm being a helpful part of the.
For sure.
Yeah.
I
I
was
just
surprised that like you guys like I didn't know anything about singularity theory, so I just hear the basin gradient. That's all
I also
remember.
don't know much about it. I only heard, it's second hand seeing people talking about it and
That's my
right?
experience too. Like my experience is seeing people who know singularity theory talk about singularity theory, and then
And
seeing those
I
words
guess
applied, and that's around it.
I feel like it's kind of a meme of like people trying to talk about singular thing to explain things. It's just not that.
It feels like
Yes, apparently you need the math background to understand it, I guess.
No, I think
it
I
uses
don't know.
algebraic geometry and statistical physics.
Yes, 2 parts of math I never studied or haven't studied yet.
Anyway, going back, we just have Claude explaining it to us. Anyway, going back to this, yeah, I couldn't what they actually tested because okay, so this is just categorized by rapid learning, heads copying, overlapping vocabulary. So they also did the Mech Interp plots, which is what I wanted to see. As they can see for the diagonal circuits, vocabulary splitting head minimization precision with the honor of circuits covering continuous science. Right. The loss on this measures auto distribution loss and least recursive. A problem is this kind of thing, you can see things on the plot, but it's hard to turn that into a nice measure you can put into the paper. Because the real thing might be you just spend an evening looking at different plots and visually see how they change, right? And then it's hard to translate into the paper. You can try to find a concrete measure you can plot on the paper. You can just put the thing on the thing. There is also noticeable coding with trying to get Claude to do this kind of thing, where the Claude can't read plots. So if you want to see what Claude thinks about some result, you need to make it like some text thing. Like you can give it images, but Claude can barely see. Like it won't be able to read a plot.
Yes.
Like,
You
I
said it
was
won't be able to read the plot?
Yeah, I think it's not capable of reading any complicated plot that is not like some super trivial. It
Ah,
doesn't
okay.
have complicated. Like it can barely like I was doing another thing with Pokemon the other day, and I could barely identify which Pokemon it was, much less like read complicated plots with
Okay,
lots
if
of
you
details.
like Gemini is state of the art in multimodality. I wonder if you could like use like some MCP tool or something that just gives it to Gemini API or something, and if that would increase performance, basically.
I think other models can
Maybe
be better.
Gemini is now like okay, yeah, well, yeah, ah, that's a side step, but I wanna uh, they say that Opus is so good for coding than OpenAI and Google because they're focusing on just coding, so they don't focus on multimodality, for instance. While Google is much more focusing on multimodality, so they are leading there, but they are not
Maybe.
leading on coding because they don't focus on coding as much as Anthropic. Anthropic is just coding. But
Maybe Anthropic will then get better at coding because they get Claude to code their vision stuff.
yeah, like like recursive self-improvement. I feel like they are trying to achieve as fast as possible
Yeah.
by this focus.
The figures really. Also, I think there's probably a lot more money on coding along the near term.
Yeah, for sure.
Or like more money quickly. That is harder for the other things to adapt to.
Yeah.
But anyway, let's not talk about cloud. We can talk about later. Let's talk about the
Yes.
paper first. We already
Let's
been
jump
going
back
for
to
more
I
than
paper.
think we, I think we,
an hour.
no, we finished the paper. In my opinion, we think we finished all the implications. There wasn't much.
Not really. I think there's a few things I want to read though.
What was it? What was the thing you didn't cover? I feel like we
Okay.
covered every.
I wanna go through as much details as possible, basically.
Yeah.
There's
Okay,
a lot of details we just
let's
skipped over.
continue. The circuit. Okay, let's. Yeah. So they also do this circuit run thing. It defined as the sum of the matrix ranks of OB and KQ circuits. This measure is more specific to the modern architecture compared to the previous two, and we did improved circuits into definition. Okay. That's very nice. That's actually the thing I wanted to see, the kind of thing I want to see. For three model, the matrix rank is equal to the head dimension for each of the circuits. Okay. The sum of the matrix rank of the OB and the QK circuits. This is the kind of thing you can only do on this kind of model. Because on the bigger models, they are doing more than one thing, so you can't test it. But I hadn't thought about how, if you have a toy model that is doing a single task, you can measure how complicated the circuit that does the task is by measuring this kind of thing directly, because the model is only doing the task.
But when I think about the anthropic geometry of the counting task, they also have like this specialized heads when they do like the discretization of the manifold. So maybe.
Yeah, but maybe it also does other
there.
things in another context though.
Yeah.
Also, even here, I feel like the model might have had noise, and you might want to do things like ablations and try to find.
Yeah, for sure.
But actually, maybe
could
they're
you
doing
guys
that. I'm not
explain
sure what they
circuit
mean
rank?
by the rank.
They said like the matrix ranks, but I don't, not 100% sure what that means.
Matrix rank.
That's like, yeah, I don't know how they do that, because okay, so the matrix ranks is like how many
Like
I'm finding my limit.
linear independent rows or
Yes.
columns, basically.
Yeah. So yeah, that's how you can think of
But they're
many
summing
dimensions
the
you can.
rows and columns. So is it are they adding the rows and columns as one value, or are they like
No, it's
adding the rows?
the linearly independent ones.
Yeah, how many vectors in the matrix can you not get from the other ones, basically?
Oh, okay.
Like,
So okay, I see that's where, and then you're trying to use that to find the matrix rank. Oh, okay, that makes sense.
yeah, so let's say it's in a way directions that you cannot create from the other directions, basically.
I don't think it's like the best measure though for like how complicated it is, but But I'm just thinking of the idea of, in general, testing, like, how complicated that thing is. I think a
Wouldn't it be more
better way of
interpretable?
measuring.
Wouldn't it be more interpretable if it has more directions? Always, but
No, it just has less things. I think it will be better to some kind of measure with some ablations and see how much of the model actually matters, right? But yeah, if it has lower rank, it's on sense less complicated because you could summarize it less directions or whatever. But yeah, anyway, I don't think this is the best measure, but I just thought about it. It seems they hadn't thought about it. I think it's interesting, the idea of, with a toy model you can do simple things on the matrix to figure out how complicated it is, and
Okay,
that
like
is how complicated the circuit is because there is only one circuit.
so one thing I'm confused in the graph above though is that they not above actually. Oh, actually, yeah, it's the same one. I think. Yeah, like on the right, on the left they have these LLC and circuit rank. What? And on the right they have loss. Like on the graph on top, like they have
Okay.
what? Wait. I'm a bit confused. Like.
Okay, so this graph,
The
you mean the one with the
yeah
three colors
yeah.
here? Okay, so
Why
let's look at
why
it because I understand it.
why
So
does the y-axis represent three things at once?
okay,
It has
so
LLC, which is the local learning thing. It has a circuit rank, and it has loss. On the
maybe
right.
maybe
but
each
they are
section
just
it
Oh
measured a
wait,
different y value.
with different
no,
color lines, right?
it's the different color lines. Okay,
Yeah, so it
Oh,
just
okay.
so it just makes sense. Yeah, so circuit rank goes like
And
this and then goes down. Like
those
it's
okay.
so
And
there is an
the D
initial
are
learning.
checkpoints.
Hmm?
No, what is the D? Oh, that's the means of the normal distribution. I mean, of the distribution that you're sampling from. If you go on top. Oh yeah.
Yeah.
The D loss on D blah blah. Or
You mean this thing? Yeah, this is the
yeah
different
yeah.
distributions.
Okay.
This thing is just the how separated this or
Oh
whatever. It's just how separated
oh
the numbers are.
yeah. Okay. I see now. Interesting, and that seems to affect the loss. Okay,
And
we can stare a bit at this graph
yeah,
as
I think
well,
it's
or
a good
yeah.
thing. Okay, so the loss goes down and then it kind of stays similar, right? At this point.
Mm-hmm.
On this one, it keeps going back. The difference that this one has less splitting, has this D here, which means
Less
here,
these less difference. Okay.
starting with a data distributed. Oh, they okay. So they made a small model with this just means they made a data set with less separations with the thing with this weird method that probably
Hmm.
changes the distribution a bit because instead of they're kind of generating and then remove the highest. I won't have time to think a lot
And
about that, but it's probably like not the same distribution as if you just generate it with the less the separation of the first place with some other formula. But yeah,
less separation means
it's just the
higher
number,
loss.
the difference in the numbers. Like
Yes.
here,
But like the thing I'm confused about is that the separation, if it's lower, then the loss is worse. I would expect lower separation to be more performing, basically. Actually, maybe not
no,
because you have
the
less
other way
values.
around. The more separated the numbers are, the more the model can learn that how to order them.
Okay, because there's less of them, maybe.
And no,
No,
also
wait, they
like
still
there
they're
are
still
bigger
very
difference
okay.
between them, right? It's less
Okay,
likely that you have
okay,
to track
okay, makes sense
small
now.
swaps between them, right? Because where you are going to have more times where I don't know, you might have 8 that is very different from 1, 2, another 1, 2, 3.
Yes, that makes sense.
Separation is they mean on the graph. No, it's not on the graph. It's the data set. Like here on the graph, they have two data sets, like the 0.4.7. This is separation,
Yes.
and this is 7.2, which is a different separation. I'm just saying this because Rembert asked on the chat.
Yeah. Okay.
Uh,
And bigger makes sense. Okay.
So there's two
And
different
then-
models. One trained on this dataset, another trained on this dataset.
And the size of the vocabulary is the same for both.
Yeah.
It's
And
both are
they
50,
are
I guess.
both, and the other two lines are on the for 4.2 one.
Yeah.
Which is also like the main original dataset. Like they made this one by filtering this one.
Okay. That makes sense.
Okay.
So LLC goes up. Interesting.
Which my guess is probably they did the experiments on this first and then thought, what if we change the thing and then added that later?
But interesting that the circuit rank goes down only after the loss stabilized? What? That makes
Yeah,
no
this is
sense to
similar
me.
to the grokking
Oh, right. Cleaning up.
paper. Where it looks
cleanup
like
phase, maybe.
stabilized, but it probably goes. This is it probably goes down a bit. Also, this is the
it does.
training. So this is okay. So this is the validation loss. The training loss probably still goes down because it's getting like this doesn't show the way the K loss. And yeah, there is probably also some effect from training from like some effect from the thing where it, even without the way the case still works. I wonder if that happens more on this one than on this one, where it still goes down a bit, right? And maybe on this one, I wonder if both of these have the weight decay or something. But if they don't, maybe if you train it on this dataset without weight decay, it doesn't work. Maybe they try that. Or maybe it does, and it just like here it looks the same, but also like it goes down a bit or something. Right?
Okay, yeah.
I think that happens on the grokking paper with some configurations. Like the loss only goes down a bit, but there's still enough for game design to perform one thing on the other. Or like they even have the same loss, but there is something like the model is model is using some version grade set with momentum and some other basing. And even if the loss is the same, it's still, and if it's moving randomly, it's more likely to end in one that generalizes than the one it doesn't generalize, even if they have the same loss. But yeah.
Okay, that's actually. Oh, that's amazing connection, actually. That's a very good connection, actually. Okay, a paper idea. Let's apply this LLC coefficient to the grokking paper.
That's the cool thing. I feel like there's a lot of paper ideas like that we kind of want to have.
Well,
There's a lot of work and we want to do until Claude can just do them.
Yeah. I mean, I think if you can specify it enough, Claude can do it basically. But you just need to be extremely specific what exactly to do and use.
At least for I didn't try that much, but at least for if I haven't tried a bit on a tiny a toy model task like this one, I feel like we probably need to make a skill with a bunch of reminders and stuff and
Yes.
good prompting. And sometimes you feel you need to poke Claude a bit. Otherwise, it forgets things or gets lost or thinks it has the answer, but it hasn't actually explained it. And you said, this is a K result, and it starts saying, like I did Control F, it said, I had a long conversation with it. I was trying to get to a thing like this, and it said, this is a K result 30 times. They weren't key results. They were mostly with found a correlation between two things. But yeah.
This is groundbreaking research. Publish it instantly. Yeah.
You're
well.
connecting the loss. You're connecting the loss dropping with grokking again. Is that what the
Yeah,
connection is?
basically, we are talking
I didn't
about
read the grok.
the circuit rank going down without the loss going down a lot on this one. And also, yeah, note that we don't have the circuit rank for this one. I would like to see it, like for this one. I don't know
Yeah.
why they didn't just plot both for both. They could have, maybe they thought it looked worse, but I don't know. Like it feel like it will, be nice to just have a dotted line for the. They don't need to do this. They could just do the normal line for the 4 one and dotted line for the other one. Just pull out all 4 things instead of the loss. But maybe they
This is
didn't actually run all of the. I wonder if they didn't run all of the experiments in all of the models because they didn't store all of the checkpoints for all of the models because it's actually it takes a lot of space. Like even in 1-layer transformers, it takes a few megabytes, but you start doing hundreds of them, and it does. it
Yeah.
starts
Picking up.
taking here. I already filled my 1 terabyte of memory the other day doing a similar thing with this when I was looking at the modular addition model with Claude. I quickly filled the whole the whole memory of my computer making checkpoints. But yeah,
Yeah.
I was also curious. Let's look a bit at this. Also, yeah, I guess before that, LLC, which was the basing thing, goes up. Does that mean it's a broader basing? Which is what makes sense, right?
LC corresponds to narrower basin, they said, I think.
Ah,
Right
okay,
above.
then that actually was not right on the. It just goes to an. Well, let me.
A larger LLC corresponds to a narrower basin and therefore more complex model.
Okay, yeah. Then I was wrong. And yeah, I had no idea what's going on with LLC.
Same.
Whatever. Yeah.
That is very exactly the opposite of what I would expect as well.
Yeah, but maybe
Okay.
the singular learning people have some reason why this makes sense.
Yeah.
But yeah, I guess it. If you start with the model having very high loss, it makes sense that it's narrower than having lower loss. I guess it does go down a bit,
Yeah.
but still.
Like maybe if it would just memorize everything, LLC would be much higher. Like I would expect that.
Yeah,
Like,
that
that's
makes
my
sense.
intuition behind complexity of a model.
Here is just low because it just on whatever the random initializations just have very high LLC for whatever reason. Yeah, but I feel like I just will
that
need
makes
to
sense
understand
I think.
singular rendering theory to understand that better. But yeah.
Yeah.
Okay,
Like,
so
yeah.
what about this?
Maybe there was
graph?
no memorization phase, basically.
So this is the OB head, and it kind of looks messy, and it looks nicer here, basically. I think a nice thing you can do in this kind of thing is that you can show on a paper. You may be able to show on a thing like the nice anthropic things blog post
The
that was
animation.
kind of still. It's make an animation where you just plot all of the checkpoints as animation, and it looks. I've done this for the modular addition, like for the multiplication model, and it looks pretty nice. Have like this noise disappears and the line appears. But yeah. Also,
Yes.
yeah, I didn't actually understand fully how the circuit works, but okay, it shows this. Starts showing this line.
Yeah, I'm still okay. Like, at least as far as I understand, the QK circuit is just like nearest number token in the vocabulary that is slightly larger than itself.
Mm-hmm. And the OB circuit was what?
And the OV circuit acts as a copying circuit, copying 4 number tokens that are present in the context. So it's like copying from the unsorted list to the sorted list. In the input.
Why is like diagonal on some points though? Also,
that makes sense actually because Wait, what are exactly the axes? Score
Yeah,
vocabulary.
what is
Yeah,
the
that makes
exercise
sense
thing?
because
Oh, it's the
okay,
vocabulary.
I assume that's like input and output. So like you wanna copy 0 to 0, 1 to 1,
No, it
50
says
to
it's
50.
source vocabulary and destination vocabulary.
Yeah. So that makes sense for it to be like this
Ah,
because it's copying 10 to 10, like from unsorted to sorted. It's copying, and you want it to copy
ah,
the exact one, 50 to 50,
okay.
30 to 30, and the different heads specialize in different parts of the vocabulary, I think. Yeah. Uh, wait. Yeah, copies. Vocabulary splitting. Yeah, there's vocabulary splitting. So copies or attends to small numbers, copies or attends to large numbers. Okay.
And why does this thing here where there is like squares and they look like there is have some periodic pattern? Which can this kind of tell me there's probably some like circle involved yet again?
That's very weird. Oh, that's maybe separation part. Wait. I wanna see.
This is
I
the
haven't
thing they call
gotten to this
vocabulary
copy
splitting, right?
suppression. There is also suppression, suppressing copying and copying. So negative is suppressing, positive is copying. So you can see negative on the right. So the on top, so yeah. So the things that are on the diagonal are you wanna incentivize that. Therefore, that's positive. So that's red. And the things that are not on the diagonal, you wanna disincentivize that. So that
Oh.
makes it blue.
Why
That would make
does
sense.
this thing? I confused why it does this thing where in this part of the diagonal it's not red, but instead it does it by making these ones blue.
I don't know. Maybe like it's like
It happens here too, like yeah, right? It's doing but maybe I don't know. This is
like some heads are copying and some heads are suppressing. In when to
but okay,
suppress the
so
noise
they
from
are
the other
doing it.
ones.
Okay, no. I realize it makes sense. Okay, I understand now. So if you combine, it's doing it on two different heads, right? And they overlap.
Yeah.
Here it has the line here, and if you put these two together, these two heads together, it just becomes a red line here, a blue line here.
Yeah, and suppressing.
Yeah.
So
So
this,
Yes.
it's
so the
doing the suppressing thing. It's just for the way for the model to do it is simpler. It's simpler to split it on the two heads this way. Like okay, so on the start,
Yeah,
it's
combination.
kind of doing that when in this here is a bit here and then this and this
Oh,
here, but it's
oh,
not quite done and it's
they
not doing a lot
do
of suppression. And here
also
is
they
not
do
simpler.
ablations. And later they say that ablating the copy suppressing head has no impact on the accuracy of the model, but it does increase the loss slightly. So it's like helping the loss a bit apparently, even though accuracy is still very high. So it's like extra, I guess.
Yeah, I guess if you do the other thing, you don't. You might.
It's fine-tuning confidence.
What
That's, I
is
guess.
copy? Okay, so this is in the OB circuit, right? Because on the if you have the original model, okay. So what does the other head? What does the other circuit do? The QK one.
Uh, it's attend primarily to the nearest number token in the vocabulary that is slightly larger than itself.
Okay, so if you do that and each number attends to
Larger
its
than this.
one to the slightly a bit larger than itself, you eventually
Yes.
have the largest number attend to itself, and all of the other numbers attend to the next one, and this means, but the last on the But what do they do on the output list though? I think I
Should
don't
somehow
understand yet.
combine, I guess.
Okay, let me. Yeah, I don't think I understand the mechanics yet. It's probably not that complicated, so maybe I should before continuing. Consider means compression suppressions. Aha. Maybe it's better explained here.
Like, it makes sense because you want the attention to look at what is bigger. And that way you can pay attention to the bigger ones. Yeah. And then copy the bigger ones. And that way sort it. Something like
Yeah,
that.
but this just means the thing copies itself, right? Like that each token copies itself. So isn't this thing just increasing the number, right?
Mm-hmm.
Right. So like the always
Yes.
If I
circuit is just
understand,
increasing the number. So the model uses the first circuit, the QK circuit, to find the biggest number or something, and then it increases the number. So yeah, this is not an essential part. It's just increasing the confidence or something. So the only other thing is enough. I'm not sure I understand it yet though. But so from
what last one
3.
post is that?
Oh,
Is that the same last one post?
Oh, it's here. Let me. They mention on the paper is like the one that actually reverse engineer this model, because here the paper is not doing that. They are looking at the training dynamics. Just.
Yeah, I'll probably look at this since I'm not familiar with this type of research.
Cumulative sum. So the same circuit happens in a cumulative sum task, okay? Sequence of partial sums given a sequence, okay. Oh, okay. Okay.
Like, okay, since the model is a single layer, it has to do everything it does has to be on the attention of the of here, right? On the separator token on 3.
Wait, where is the QQ circuit exactly reverse engineered? QQuery. Okay,
The
it's
step
in the
token just attends
B1.
to the smallest token. Okay, that makes sense. I wasn't. Yeah, the step token just copies the smallest token, and that like it just has a thing where the lower the number are, the higher the thing is, and that probably maybe is some kind of a circle too, or some modulo thing.
Yes.
Or which is like in practice it's a big table of numbers, but there is some nice structure that makes it easier to learn. but yeah.
Attend back to and copy the first token which is larger than me. That would make sense. That's what you need here as well.
And then 3 attends to the 5 because it's the next largest one. Okay, so yeah, the numbers just attend to the next largest one. So I'm guessing they also just have a big list, some kind of circle thing where each number like has a higher value, and you just get higher k, like smaller distance between the k and query vectors when the numbers are bigger but the slash it closer. Like in the bigger numbers, the closer they are, the bigger the match is, and that's it. And I wonder how it does. So the smaller numbers are very the difference is very high. There's probably some very cool structure to do that. Like for each number is similar to the next one, but not to the previous ones. the seems non-trivial to implementing with linear
Ah.
algebra stuff, but yeah.
Second 3 token attending back to the first 5 token. Second 5 attending to 7.
Yeah.
Okay. Different heads specialize on different ranges. This is also very similar to the geometry of counting task.
Okay, so going back to the thing. Okay, so this makes sense. They talk more about this on the other. I want to say the other circuit, but okay.
Yeah. So at position 5, predicting after 3.
Okay.
Current token free context contains. So okay, so if we're okay, so we're in
Yeah, so if I understand correctly, this is just the model, like, okay, so here 3 the k query matrix attends to 5 because it's just the slightly higher than 3, and then there is another head, so another part of the circuit, the OB circuit, just takes this 5 that was copied and increases it and suppresses the other numbers. Just to reduce loss, I guess.
Yeah. If token is free and context contains 7, 5, 12, 3, Yuki circuit attends to the smallest token larger than me. So for free, that's 5. And the OV circuit copies 5 to output.
Yeah, you can, and for that, it just needs to have the attention score be larger for nearer numbers and higher for numbers that are farther away, but very low for numbers that are smaller, which seems non-trivial to do linearly, but yeah, I guess it can do that.
And then it does the 7 1. Okay, that makes sense actually. Key value. Okay, that makes sense actually. You first attend to the token larger than you, then you just copy it using the value. Okay, I think I get it now.
Okay, so next, they do that. So they show this. This is just the thing. It wants to just do a line here, and the interesting thing is that it learns to do this split thing that is smaller. It's kind of already doing it here, and it starts doing it on on this thing, which is when the loss goes down. It kind of just appear. And before that, it was kind of doing that, but not really. And it just starts, and then the circuit
this is just the OV head.
goes down. Yeah, and
Oh,
here,
right. Okay, they just show OV heads. They don't show the.
Yeah, I want to see the other one, but
OQ.
yeah. Kind of wish we had the code to just I could later just plot it and send it on the channel or
Yeah.
something. As Claude
This is what's
plotted.
actually copied. Okay.
Okay. Yeah, so this then they do the interesting thing is they look at different circuits. In this circuit we focus circuit relations and leave the key circuits for app. Wait, what?
Wait, but why is it?
Oh, they
Why
do
do
it.
they
They
show
show
just
the
copying?
circuits here. They do it here on the
On
appendices.
the bottom.
Whatever.
That's more interesting to me. The copying seems boring. I wanna see the other one.
Okay, let's first quickly finish.
Oh, I
this.
see.
Okay,
Wasn't the
so
copying
okay,
one? Wasn't the copying one suppressing previous things?
oh yeah, it also is like because different heads specialize. So if
okay,
one specializes, you wanna suppress the other one to not give you best.
find that this is dosing at very different way. Like it's doing. I think it is interesting because it's easy to see the pattern. And it learns it different on this thing. It learns it a very different way.
Wait,
And I wonder.
how do they
Okay, so
differ?
yeah, so there's these squares, right? And here it does like a lot. It's like a lot more tiny. Wait, actually, isn't this? I'm
Two-head
confused by this
modular.
one. I think this one is kind of. What is copy suppressing thing? Actually, I think we
Wait,
were.
baseline two-head modular, train on D, and the second thing is, oh, there's a smaller D. Wait,
The circuit run at the loss evaluated in.
Oh, I'm just realizing it's not, it's the, why do they show loss? Because they wanna show generalization. Oh my god. That's one thing I showed it wrong. Like the first graph, so this is just all one model. It's just loss on different data sets. So the first model is trained on the is that theta? I forgot. But yeah,
What?
Okay,
So the
okay. Sorry, yeah, you're
4.7.
right. It's loss on a different, the same model, loss on a different data set. Yeah, okay. I think you are.
So
Yeah,
the
Yeah,
I noticed.
is the top one the first data set, the bottom one the other data set, or are they from the same model? What?
It's the same model. So this is the same model but on different datasets. No, not okay. So, I mean, this is a different model than this one, but we mean the dotted lines are the same model on different on the same graph and the same model on different datasets.
Okay, so how do
I
you know
see.
which model is which? They made two different models. I thought they did one for the
No, this one is the
copy
one
paste and the
on
other.
4, and this one is the one on 2. And you can see that the one on 4 also has even lower loss on 2. So like it's generalizing better as it goes on a different dataset.
The first one is trained on larger differences.
Yeah. Oh no,
And
wait.
the second
I
one
know
is
it's
trained
not
on
generalizing
lower
better.
differences.
I was switching it up. It goes down on the actual thing, but the thing on the smaller difference doesn't keep going down. Okay, yeah.
Yeah. But the second one I'm confused about.
Okay, yeah. Let's see the
Like I
second
would
one.
assume
The second one also has
like
the extra copy suppressing thing, which I'm not sure I understand yet. Which is also the thing that was on GPT-2.
but develops copy suppression at the end of training.
Okay, so
Wait,
what's
so the
copy
first one doesn't
suppression
have copy
actually?
suppression.
What is
I
copy
thought the
suppression
first one
exactly?
also. I thought the first one is copy suppression. Wait.
Okay,
Okay.
because vocabulary is splitting and then it does copy suppression. Why is it? Okay, why is this blue? Isn't that like the opposite of what we want? Or I guess it's maybe not that blue and this one just
Oh,
overlaps.
I see now. Now that's the copy suppression one, the blue, and the red one is the
Okay,
copy enforcing
why
one.
do you want to suppress copying though? Oh, wait, are you? Is the
Because
idea that
yeah,
you want to suppress 3 to get the 5 that you're getting from the
yeah,
list? Okay,
yeah.
but how you separate to suppress 5 without suppressing 3? Right? I guess you represent them differently, but then that doesn't show up well on this kind of plot because it's just looking at the source vocabulary and destination vocabulary, so it's just probably taking the embedding and multiplying by the OV circuit, but the model is likely doing some different value thing with the positional embedding where it suppresses the current one and it takes the other one. right?
I don't. They didn't add positional embedding, no?
Hmm.
That's not in this model.
Then you can't
Yeah, like
really, right? Then you can't
so
really.
you take the vector of 5 and run it through the attention heads. One of them will kill it, and the second one will enforce it to be copied to the output. I want more concrete examples.
Like on the 3, on the 2. Yeah, I know. I'm not.
I wonder if
Sure.
Claude can do this. Give me as concrete example as possible from input being transformed from the very beginning to the very end.
Because the OB circuit happens after the other one, right? So also, they will have a lot of people here today, even though I feel like we are not. I wouldn't have thought this paper was that as I mean, it's interesting to me, but I don't know. I also nobody is talking, so.
Yeah, if anyone else wants to chime in, feel free to.
Yeah, like I feel like we have a lot of new people that maybe be disappointed we had today was kind of a mess. But
I feel like it's always you and Bernie always talking. So that's the common thing.
I mean, I think it is better than when it was mostly me. But yeah, I maybe I should do more that the thing that yeah, Alice does that when she just pokes people to make them talk.
Well, but like, no, I don't think everybody can necessarily talk.
But yeah, sometimes they're just not talking out of shyness or something, and then it's better for them too. But yeah.
Oh wow,
Anyway,
okay. Complete forward pass. Claude is trying to generate. Do you wanna try to look into at that?
I mean, maybe I don't.
At this thing?
I don't know how well Claude will do when it doesn't actually see
Yeah.
the graphs, but yeah.
Yeah.
How are you able to determine like when you guys are satisfied looking at a paper? I notice you guys always stick longer than like I feel like the author initially like you connect like some of these points I feel like weren't from the paper directly.
I mean, I think it's interesting. I mean, people want, we could just end it, but I don't know. As long as Bernie wants to keep going and people haven't left, why not keep talking about it? Like, I mean, I understand
I
maybe
wanna
you want to
understand
talk
this.
about something else, but just interesting now. So
Yeah,
uh,
same.
I feel like
What model?
we also kind of lost the first hour where it was between me having technical problems and also getting distracted in talking about the philosophy of whether small or bigger models are better or whatever to do research, which is nice.
But it's
Maybe we
stable.
should.
It's a very inefficient way to learn.
But
Yeah,
your connection stabilized, so that's good.
yeah. And
And
maybe
we
I mean maybe
eventually
we
converge on
should
actually reading.
actually read the paper beforehand instead. But at the same time, this is also nice. I like
Yeah, you
reading
can
the
read the
papers
paper.
here with and talking with other people. But
Yeah, you can read the paper.
Single layer attention only, no MLP. Okay, 2 attention, that's layer normalization. Do you wanna go through the Claude example? That and maybe if we can spot errors as well.
you could, I
No, this
guess.
feels more like this. This feels like we're like looking at Claude and understanding. I feel like with how we're going, trying to understand this, it'd be interesting. We try doing like singular learning theory here. Paper.
I mean, yeah, we should learn theory at some point, but yeah, I don't think
Yeah,
it's
I'm
that
saying we should try
relevant.
at least a
They
few papers. I
mostly
think.
just use the LLC thing anyway, so
Yeah.
this is mostly
Yeah.
just tiny model thing. But I feel like we could just fully understand this tiny model. Like it's just explained here. We just need a bit more. I feel I understand most of it. I just don't completely understand the copy suppression part yet.
Okay, how did Claude try to do copy suppression?
covered by one head decreases before switching to copy suppression. Okay, so maybe it springs better here. This is hard because it's happened where the thing fairly contains loss and LLC and constant circuit rates. At circuit level, the stage by clear the dragon station the OB by the OB diagonals of the two heads overlap. I don't have a splitting vocabulary yet. So yeah, this is just on the copy suppression part, the head overlapping thing is just the two heads are just having a diagonal. And then it was popular splitting, which I do understand. Centers they are dropping the distribution loss, but not in the auto distribution loss, and decreasing the LLC. Okay. On the circuit level, the stage characterized by a clear separation of the vocabulary between the heads, with OV circuits non-overlapping. When training on the 4 one, the 4 separation one, the LLC drops moderately before stabilizing together in the other measures. The models. If we instead train on the 2-1, we know the model levels are now number of continuous regions in the OV circuits, which makes sense if the distance are smaller, probably. I will expect you see like the more smaller it is, you see more tiny regions, maybe, or maybe this is just a random effect that we should want to see more. Supposed to be basically
Makes
model
sense.
in the number of regions doesn't stabilize, and the vocabulary regions in head one decrease throughout the states. Compared with a simultaneous decrease in LLC. Okay. Okay. When the training on the reaches the minimum as the region says at a negative diagonal concentration starts to form.
So the LLC. Oh, okay. So in the first model, LLC only increases,
to
and
copies the entire
in
vocabulary
this,
range.
okay.
Since the QK circuit of both heads are similar, we conclude that head 1 is doing copy suppression to similar to what's been identified as CPT does. Very true. Okay. To is highly similar within this stage copy suppression. In this stage, the model set into training. Okay. In Appendix B, we vary the number of heads and remove learning. Oh, there is more stuff. Okay,
Simpler solution that is more specialized?
I feel like they didn't
What?
figure it out. I feel like maybe they didn't figure out how the OB circuit thing, like the copy suppression thing works. Like why does in this head does copy suppression and this head it does copying? Like I suspect this just an artifact of this plotting, and this is actually somehow doing something different on the current number than on the number that comes from the other attention on the other model, right? On the other circuit, right? Like it has to somehow suppress on this example. It has to somehow suppress 3 and where was it? Here. Here it has to suppress 3 and increase 5, and it has to. So this plot
And
looks like
copy
it's doing
5.
a weird thing where one head is increasing the same number and the other head is decreasing the same number. I'm guessing this is just this head is suppressing the current number on the current position, and the other head is suppressing the other number in the other position. And I don't know, maybe it does that. I don't know if they have a different positional encoding and it just use that, or if it just does a thing where it knows the position because like it spreads attention more on one of them because if it suppresses the current one, the other circuit is going to have more. I don't know. It's kind of hard to figure out. There's something with the other one has more attention because there is less numbers or something, or like more. No, that doesn't make sense. I don't know. Kind of hard to figure out. Seems like it will be very hard to separate here with only one layer and no positional encodings, but maybe they do have positional encodings.
Copies. Okay.
Like otherwise, I don't see how the model is able to do. Like if you have more than one attention layer, you can do clever things with, like using the position you are at to figure that out. But with only one layer, you are already do it always on the same position, like on the last one, right? And you pay attention to the previous ones, and you can't do, since the thing is symmetric for the different positions, you can't really do a thing where you do different things with things on different positions. So yeah, no idea. I don't think they explain it here, or they probably didn't figure it out. I will have to see what. I mean, maybe the original copy suppression thing explains it better there. But yeah. By the spread there, it just has a positional encoding, and you can just do, suppress the current one and not the other one.
Context.
Oh, but okay, but you can.
Copying head.
Oh, you can do a thing where see the current one is a key. Maybe it looks like this, but you can do this because the current one is the key. So maybe you just this is just a thing that is harder to see when you separate this in a OB circuit and a QK circuit, but you actually do. I don't know.
I'm gonna try to go from scratch.
I think I want to read the whole thing first. Too. Okay,
Yes.
let's keep going and finish the theme first, and then we can try to figure it out more. So, because maybe it just explains better later, and we're just wasting the time. Okay, so it does
That's
this
also a
thing.
possibility.
It does this distribution, which is the. Maybe it's nice to do to think first, and then we have some evidence to like, and then we can see if the rest of the paper matches or the thing we thought earlier. But yeah.
Yes. Guess the paper.
Predict the next token. Also, yeah, people are leaving. Makes sense. We've been here for a while. Distribution of this thing. In this. Okay, so it goes down. I'm not sure I understand. What's this plot? Distribution of this separation between the variables is missing. Okay, so this is just the distribution of separation.
This is just the data set.
Yeah.
Right. Yeah.
Okay. So
Okay.
yeah, so it's just different numbers basically. Yeah, it's just these ones are more separate, are like oh wait, no, what? I'm confused. This isn't
Count. Oh right. The bigger separation, the smallest amount of numbers. That makes sense.
wait. No, but this has bigger separation, right? Why are there more
Distribution
numbers
of-
on the bigger separation ones?
Distribution.
Oh, but okay, this has a bigger. This goes to 35. So I guess there is more data here because here they filter it. No idea.
I'm a bit confused here. Like
Yeah, I'm also confused. I think this
distribution
might
in
be an
data set.
artifact of the fact they made this dataset filtering this one out. But this seems like a messy way to show it. Like this is like a really weird plot. Probably makes sense on their head, but it's not.
What?
So
like, but in the you already have fixed data in the data set. Why are you now varying it? like you vary even more, I guess. And the more you vary, the smaller numbers you get. So it's like taking a subset of, I guess.
I don't know why. Sorry, can you? So this is just
Like,
the.
yeah,
This is just
like
showing the two data sets.
yes, the data set that has the distance between the numbers 2.2 and the data set that has the distance between the numbers 4.7.
Mm.
The theta thing. That's the theta thing, right?
Yeah.
I-
I thought
and
yeah. So yeah.
and then they do distribution of the theta for the data set that has fixed theta. Is that a different theta? But we haven't looked at the definition of theta of the theta thing. So that might
It is
or
this thing. It's the sum of the list of the. Okay, data is here. Okay, it's just here. Is so this is probably just doing. I mean, so this is the difference between the current number and the next number. Yeah, it's just the
yes.
difference between numbers. I think this is just doing the average of the difference. Yeah, this is just the average of the difference of the numbers, but broken on a slight confusing math way.
Oh. There's two different thetas. One has the thing above it, and the second one doesn't. Right? It's two different symbols. Also in this graph, right? Yeah, also in this graph. Okay, it's a two different
No,
thetas.
it's just the mean, where the thing here says the theta stands for the mean theta.
Mm-hmm.
Yeah, this is just the mean. The one thing with the thing is just the mean.
Okay. So given mean 2.2, you have different lengths.
Yeah,
Okay.
this is the separation. But I guess this is just like it looks okay. I was confused because this looks bigger and this looks smaller, but it's just that they are not using the same scale.
Yeah. Yeah. That's
Also, this
okay.
just
That's
has
true.
more numbers than this one. I'm guessing it's because they made this one filter in this one, so which is
Mean
why this one
4.7.
has a D on top, which they mean this because
M-
they made that by filtering the biggest numbers. That feels kind of
mean 4.
silly.
Mean 4.7, which means there's yeah, the average is bigger, so there's more.
This is
Okay.
this is a weird way of doing things too. I guess they want to keep the vocabulary 50. So if you want to to make no, they could keep the size, right? And just do a different distribution. So you could do the things. You could just pick out another list of numbers with smaller thetas, but for whatever reason, different distances, for whatever reason, they instead this thing where they start with a data set distributed this, with the 4 thing, and they iteratively remove the highest difference list with some probability. I don't know why they do that weird thing.
Okay. That is interesting.
And that's why this dataset has a D on top. It's not just some random dataset that happens to have 2.2. It's for some reason randomly filtered from the 4.7, and that's why it's
So that's
less
what the
numbers.
D means.
Yeah, and that's why it's less numbers than the other one. And yeah, no idea why they do that though.
What? Okay, interesting. That feels ultra random. Is there like some justification for that?
I don't know.
Maybe to incentivize generalization or something?
Yeah,
Th-
maybe. Maybe they
That
have
would
some
make sense
massive
to me.
reason for to do it.
Like,
But yeah.
Yeah, the dataset being noisy in a way, like not being, I guess.
Yeah, I guess if they want to test this weird, what happens with this weird new dataset is okay. It's just kind of random, but yeah.
Yeah, that's why it's, I guess, adding noise, I guess, somehow. Or it's not really adding noise.
Yeah, this
Adding
is
yeah, less bias in the input.
it's a war out of distribution performance and the layer dropping the LCP was okay. Well, this feels like the problem is that they don't actually understand the solution and they can't. They haven't fully reverse engineered the model, and they even if it's a tiny model, it seems like they are almost there, right? It feels slightly annoying to me that they didn't actually do that, and they have to do things. This was auto distribution performance. I understand this is hard actually. For having actually tried to do this very hard, but still, it would be nice if they didn't have to say this. The model has learned a simple solution.
Simpler solution that is more specialized. I
Yeah,
would
it feels like
assume.
you could just
Simpler
say,
solutions.
okay, show why, like show, okay, so it did this instead of this because you just understand the attention pattern, but they didn't
Yeah.
actually do that. I feel like that's
Like,
very doable. Like that maybe a favorite idea. You can just have figured that out.
aren't simpler solutions usually more general though? Or not?
It depends. Simpler
depends, I
solutions
think.
that have the same output on the training data, yes. But it might be a more complicated solution. Obviously, they are more complicated a solution that does nothing. So
Yeah. Okay. Okay.
like that's the thing. That I think that there's some ways when transformers don't generalize to different lengths because sometimes if you train with only a smaller lengths or something, like the model is easier, is simpler for the model to generalize to the smaller subset of
Yeah.
the data instead of doing a thing that relates to more data, and you will need more varied data sets for the model to for it to be simpler for the model to learn the more complicated thing. That's the slightly more complicated thing, but it is simpler in a broader data set.
Yes, I see now. Like different ways
But
to learn
yeah,
different modular addition, for instance, algorithms
yeah.
for different subsets of modular
Like
addition.
yeah, the modular addition, you might like for example the modular addition model just learns a thing that works for those 120 numbers and it will then learn a thing with more
Yeah.
numbers. But I
Yeah.
think they might mean that, but I'm not sure. Okay, so
Probably.
the only high head, no head specialization can be present, makes sense. We increase the number of heads to default, which is two of the heads specialized into vocabulary splitting heads, with additional heads into the full vocabulary copy suppression and full vocabulary copying. Yeah, I still confused between the copying and copy suppression, and you have both, and what the fuck is going on there, right? Like how they separate because you want to copy the current thing and not the other thing, and if you do both, you are either mostly copying and the heads are doing, opposing each other, or maybe the heads are canceling each other out and doing nothing. Uh, unless they somehow do it different on the current number than on the number on the previous list. But yeah, additionally, we find that removing and if you have two layers, you can just do it. Like it's very easy for the model to do something like, for example, do something with the separator token where you copy it and add something, and then the numbers with the separator token get higher scores, so the numbers on the second list get more than the first list, or do something with the number of things. But in one layer is kind of harder. But I think you can do something with the K and query thing. But I feel like the paper didn't actually figure that out though. I don't know if with this actually figures it out. The thing is, on this thing, they don't show the copy suppression. They don't find the copy suppression right on the original result. Because they train a different data set where it only does. Well, does it say something about copy suppression here? Or
This should be copy suppression, no? Because it's
oh yeah, no, yeah, you're right.
diagonal
It does do
blue.
copy suppression because it's blue
Yeah.
here.
Yeah, attention to Y boosts Y a lot and suppresses the other one a lot, they say, after under it. Right after the copy suppression, yeah.
I can copy the first token, which look at me. Oh, I think this is just talking about the other circuit.
Hmm.
Okay, I don't know. I'll go.
Head 1 is copy suppressing, head 2 is copying. Okay, it wants to... Correct answer is 4. Therefore, Q key is the attention, right? Q key.
Yeah.
Yeah. Q key, guys, the attention. OV acts as a copy. Like it's like Q key and value matrices. Okay. So Q key attends to 4, right? Copy. So this is copy.
Okay, I'll keep reading a bit. Okay, so yeah, it does
Hmm.
this. Y drives head specializations. Okay, that makes sense. Mean regular loss. QK head here.
I'm
If I
surprised you're like looking at these two heads for these two head types so long deeply. Like, why instead of looking at the original paper, why don't you try reading the paper on copy suppression and the head split, vocab split?
I
I feel like that'd
go
be
back
more.
to reading the thing, but yeah, I feel like if we just could fully understand it, I think it will be easier for everything to.
That's why I'm starting to fully understand. You should read two other papers to do that instead of simply
Yeah,
just
that
looking
makes
at like
sense.
the paper built off.
The number
I
of
feel
the
like you
top
guys are trying to
recovery.
understand the full paper by looking at the paper itself. I think it's kind of inefficient. You can just look at the paper.
The thing is,
and know what
the thing they are citing is this less prose and it doesn't actually explain things that a lot more. It does a bit, but still. Anyway.
Maybe if they don't ask.
We define number. Anyway, let me read the next thing. Define. The model is sensitive to short wave regions, which reflected in the higher mean losses showing tab. To capture the degree with QK, attends more to smaller tokens in a given active region. We define the mean QK gradient. The gradient of an active region there contains rows or third column. Okay. Okay, so they are looking at the QK heads now. Yeah, so the QK circuit on the head 1 and head 2. and this seems like it's specializing like in different paths. So yeah, it attends more to the higher numbers and less to the lower numbers. This kind of breaks.
Yeah, like they are differently specialized, the different heads. One is for lower, one is for higher numbers.
No, I also mean on the they do both things. This probably relates to why on the QK circuit does this. Oh, they do grain stuff. Oh, this seems interesting. The process, the stronger the mean normalized QK grains of the model, the better the sorting of neighborhood segments with small separation. Yeah. Smaller the difference. The sets are larger grains within active regions of the KK circuits, leaving region size down a number of regions up. The way to use the solution that the elements in the schematics are linearly decreasing with the database regions, and the gradient is the same for all rows in the region. Furthermore, some of the region, the obviously is constant on the diagonal. The difference in attention paid to neighboring related elements with the same ranges is only decided by difference in values of corresponding round elements. This difference in corresponding round elements is then proportional to the
Difference in
gradient.
attention.
For example, they have example size. If the sort list contains 10, 12, 15, and the current code is 10, then head to region 7 does the sorting. The OB copies both 12 and 15. 10 by the QK is 0 in the diagonal, suppressing 10. Okay, but
0 on the diagonals?
yes, the
Shouldn't it be
QK
negative?
the QK just does
Oh.
copy suppression too.
Oh, okay, I see. That means.
And that
that
one
makes
actually
sense.
makes sense because that's one thing that with QK you can totally do that. You just can suppress the current one and increase the other one. Wait, what? Then the display. Wait, what does the second one does copy suppression then? Like if it is already being the current one is suppressed by the by the diagonal being 0, you don't need to, right? You don't need to suppress it. You should want to increase it instead. Yeah, no, I'm confused.
I'm now trying also to look into it, but from a different angle maybe.
I just keep going. To finish the paper already because we've been here for hours. I think it was interesting, but I worry that all the people listening to us were bored or something. And maybe I need to pick papers that are easy to read or read them beforehand. But I just wanted to. Next week, hopefully, will be more interesting for more people because we'll have. I'll try to get the authors for the Neil Maths paper, but yeah.
Yes.
Leaving region size down a number of regions up. Okay, the weird intuition for this but is assuming that the elements on rows of the QK matrix are linear decreasing with the two regions, so that the gradient is the same for all rows of the regions. Well, assuming that it is. Okay, yeah, so. Yeah, I'm looking at the section towards the end before the discussion. Like they have an example of the how they think the model works there, which is nice. Elements are linear decreasing with a slope equal to a gradient. Then the difference between the two matrix elements is given by its separation. 3 in our case, times the
Where does
gradient.
it say that text? Where does it say that?
Oh, it's on like
No.
on top of discussion, like here on the end.
This is for the copy suppression, right?
No, they are actually just explaining how this circuit forms, like why this gradient on the QK circuit and the OV circuit happens. Which is, I think you're mostly talking about the QK circuit.
Okay, so for copy suppression, both heads have similar QK circuits, but head 1 has negative OV diagonal, and head 2 has positive. Okay, I see now. I think I'm seeing it now. Let me go a bit
Why
more.
do you want to suppress copying though? That's the thing I'm confused. So you want to copy it actually?
Okay. Okay, let's try to find answer for that. So implementing you have this. The context, the model can add positions for tokens. Okay. QK circuit determines who to attend to. Both had some similar QK circuits in the copy suppression regime. So both heads look at 4. The QK circuit says attend most to 4, smallest because it's smallest number bigger than 2, right? Then you get attention pattern with softmax. Okay. And OV circuit was gets copied. So you wanna copy everything, but attention is on 4. And suppress, but you also suppress it? I'm confused. Okay.
Yes, that's how I
So
understand.
you
Why
also
is
suppress
the
it?
copy suppressing at the same? Like, why do you want to copy it? Why is suppressing the thing? Like, what?
Legit. Okay, so you have okay, head 2 copying just copies the token 4, right? Head 2 legit. Wait, what? Wait. Suppresses token 5. Wait. You have attention scores. Both are 0.4. Makes sense.
Spitting a simple state.
Why are you also suppressing it though? What's the point of that?
Yes, I don't understand what's the point of simple expression. Okay. Here there is maybe an explanation of 4.3. Maybe something goes for you. Copy suppression helps calibrating the copying head. Okay. Copy suppression has precision content. Affirmation but is making confiscating copying, attention, and suppression. The copy suppression will serve reserve vector.
Your
feeling-
mic is in a pocket or something, and it's making
Yeah.
noises, Rambert.
Oh, my bad.
Okay,
Yeah,
thanks.
Okay. Uh, I think we are also boring Rambert because he's not that interesting in this thing.
No, I'm right now on transit. I'm going to the Constellation office.
Oh, nice.
Okay. Where one directly suppresses the other copying head. Why?
Okay, no, but they okay. Let's go to the 4 point. If you go to 4.3, I think it maybe explains it. Okay, so copies towards a different head precision. Yeah, okay, but what does it do? Can we see comparing?
It's considerably lower.
Oh, this is pretty interesting. They put a lot of the most interesting things on the end. This is interesting. Hey, Fear! Functional role of copy suppression. Nice.
Yes.
Here, this is what I want to know. The authors investigate multiple hypotheses of the role of copy suppression.
Oh my god.
So,
Okay.
so that's had gravity head to the copying heads. So the authors didn't know. Okay.
Reduce our confidence, contributing to self-reform. Oh my god.
But wait, we will have to read the thing. Also, I find that this sounds like a paper is actually a less proposed. If I know, I think this one is the paper. The other one is not. The less proposed the McGrath point B or something. But yeah,
I took a look at it. Oh yeah.
yeah,
Arc
it's
okay.
this one is the paper. They
Self-repair.
also it's the Hydra effect. Okay. And the first one is what the copy suppression. I don't remember the copy to suppression paper though, but I think in the copy suppression it made more sense because it was, using multiple layers and then you can suppress a thing and okay, yeah, never mind. They find support for both hypotheses and the papers. Wait. After the copying heads and get copied token as part of its input. Yeah. Work in parallel with the copying heads. Important difference as the case. Okay, in our model, copy suppression seems to play a supportive role in slightly modifying the copying attention head. Huh. We find some evidence deciding this model conference operations still decreasing it.
What?
But why?
What do you mean? It's sort of like decreasing the confidence, or however define confidence.
We have latent head insertion from the model in freezing by selecting the ablated head output.
Increase the loss.
Ablating the copy suppression has not questioned the accuracy model, but this increases losses slightly. O sea, yeah, it doesn't.
What?
It just changes, has a very small effect. Now that just means, like, the accuracy you are doing argmax, so it's much less sensitive to small changes. So this just means the
No.
copy suppression is
Why does it increase the loss slightly? Because overconfidence
Wait.
means more overfitting, maybe. So this is like a regularization, maybe.
Maybe it's
To
just a
generalize?
regularization. Maybe it's just.
Yeah. Okay.
But the actual
What the
pattern, right? It's not copy suppression. It's just a diagonal that has this thing to make it a bit lower, so it's not as overconfident.
Like it is technically suppressing the copying. So
No, but I'm thinking that you added to what these two just get added, right? And it just becomes a diagonal.
yes, but like the
But
suppressing
it's
thing
less
is much lower.
slightly, right?
Yes,
It's
you
less.
see, or wait. Yeah, you see the order of magnitude, or it's not really. Like you see the bottom one has like 0.05 on top, and the top one the suppression is 0.02. So like it's much lower. So it's just
Yeah,
like
so
slightly
this is
penalizing
just
it.
I think it's just so this is in the end the pattern is just a copying pattern again that is increasing the probability of the thing as this one does, right? Well, actually, this is copying for the source vocabulary to the destination vocabulary. So this is just taking the embedding the current thing and making it into the unembedding version,
Yeah.
right? But this in the end is just doing that. It's just that this one is bigger, and for some reason, doing this thing where you do this fully on one head and is in slightly decrease it on the other head to adjust it is
Yeah.
it's
It's like
the model swatch
you're
is doing this
much.
mess into this.
Yeah, it's like you're overfitting stuff just a little bit. Calm down, calm down.
Yeah, and it's curious that
Bonk.
that the model goes from kind of doing a diagonal to doing this mess where it does some parts on different heads to going back to doing the full diagonal here. But
That's
only on this model. So only on the model train on the two data on the
Copy
smaller
suppression.
data set. On the bigger data set, it just does the splitting thing. This is
Initial
probably
learning.
related to the fact that here there is a lot more small bits, and maybe that's worse for some reason. And it's easier for the model to go from like this for these all small things, easier to just do this.
Interesting. Okay, so it first like is noise, then it's like
This
head
one
overlapping.
generalizes worse to the bigger one also, which might also the LLC goes down, and the other one it just stays constant. But here it goes down, and when it finishes going down, it starts doing copy suppression. So this means this is like a less narrow, like it's a bigger basing or whatever.
That makes sense, probably. It seems like less specialization. Like first phase is like
But it's
noise.
still
Second phase
generalizing worse
is like,
to the bigger dataset, though.
but it's simpler.
Yeah, I know.
It's simpler but less general.
I don't trust LLC as a measure of simplicity.
Okay, probably yeah. That's a good point.
I mean, it has
It's more
lower
flat.
rank. It does has lower rank, which is a better measure of a more trustable measure of simplicity, I think.
Oh yeah. Oh yeah, and it kind of correlates with LSC.
Yeah, but not on the other one. Here it just goes down, and LLC just stays constant.
Okay. So, but this is interesting. Like first it's noise, then it's like fractured overlapping for both doing the same thing in fractured way. Then it specializes into this vocabulary splitting, and it's like fuck specialization. I'm just gonna go to general again, but I'm just gonna suppress a bit because I'm too overconfident and I will not generalize.
Yeah,
If I'm too
I'm
overconfident.
confused why the model doesn't just at that point just do everything on this one and put zeros on this or something. Well, that would be harder, maybe.
Like maybe it's going too fast, the up, and like this is like a patch on top of that basically. So maybe if you would train it for even longer, eventually it would like stabilize even more, and the first head would just
it
delete
would have
itself.
even less circuit rank on the unliverless norm if it did. I guess
Yeah.
so okay. So this way, okay, I can see why this is better, right? Because this way has lower. If you're doing with decay, this has lower norm, right?
Yes.
Because it only do it in one head.
Yes.
Like if you got one head with higher numbers and this one has lower numbers, it has lower norm.
Yes,
so weight decay makes it more. So
weight decay
we should see what
incentivizes.
happens with the weight decay. We did also test it, which is nice. But yeah.
Wait, this isn't weight decay?
I don't know if they. I think they did use weight decay here, and they remove in the appendix. They try without it.
Oh, okay.
But okay, let's finish. I think it was nice to read this last session, so let's read the final thing. Okay, so
Yeah.
propose more. Yeah, they have this theory which seems neat, and so I completely believe it. That like smaller out gradients. But I'm not going to get back to that right now. Let's keep going. Copying head. Also, I can see why Neil might not like this kind of thing that is not very pragmatic in terms.
By the way, yeah, by the way, in the AI alignment meetup I was in, there was Neil and there was author of like singular ring theory, and Neil and they were talking, and Neil was telling him, your theory is fancy, but I want some practical things from it.
He was practical in
I
terms.
think, yeah, already was going in that direction. Kind of feels like Neil wasn't satisfied with it.
David Bow was there, he will be arguing against Neil because he, in the latest Mech Interp thing, apparently, workshop, he made a talk about why he wants curiosity-driven research instead of pragmatic interp. He made a fancy
The
talk
guy
about, I
of
don't know if you saw it, about how
behind singular learning theory.
not about singular
The
learning
guy,
theory, just about against the pragmatic interp blog posting.
like the same guy that's author of this paper.
No,
Or you
David
mean?
Bow.
Okay, yeah, the one who showed at the when we read also the Neil one. Okay, yeah. Okay,
He
yeah,
made a
I see
talk
now.
that is there has slides on that talks about makes a comparison to Galileo and like pragmatic glass blowing instead of making telescopes.
Okay,
Which I thought was
yeah,
funny. Pragmatic glass blowing and shows a picture of glasses.
like a literal talk. So he that article in a video form basically, or
No, it wasn't a talk. It's on the slides.
okay, so it's the same slides. Okay,
Yeah, never
yeah,
mind. Let's.
okay,
Yeah, he also. Yeah, I think he also put the thing on a blog post or something. But yeah.
okay.
But yeah. Let's go back to the paper and finish it already because we've been going for a long time. At least now Discord works. It's kind of annoying. It wasn't working earlier, but.
Like the smaller mean driving region size down, number of regions up, kind of makes okay.
Yeah, it's also
Number of
what
regions
we
up.
what
Okay,
we
whatever.
thought was happening from looking at the thing earlier, but I do wonder how much that's true on other models. And so far, they only shown 2 models.
More data needed.
I feel like it would be very easy to try more models and to test them. But well, I see this kind of thing, and then I probably when I publish the modular multiplication thing, I probably won't do that much things. So.
Yeah.
Inspire is much a mess and much more annoying, and mess and in ways that it might just get solved by Claude just start doing it. I think, and also I might not publish the modularization thing because it turned out the answer was actually not. I wanted to investigate a thing, and I don't think that one does it generalize to bigger models because turned out the answer was the kind of silly one. But yeah, I don't know. It's interesting.
You mean your project?
Yeah, for the modular multiplication thing. But I'll talk there's another day about that.
You said that
I kind
it
of
learned
switched to
some very weird structure.
studying bigger models because of that.
Okay.
I don't know.
Makes sense.
Because I went a bit back recently to test Claude, but yeah, I don't know. I think the model just turns out it can't reuse the same thing for the two. I was trying to see how it generalizes. Turns out it just can it just can do the same thing for the two tasks, like and it just learns to make the embeddings on the definitions the same as the embeddings on the original numbers, and that just works. It's okay, makes sense, but it's kind of not the obvious, like the more simple thing, and it's not the. It's kind of a negative result, I guess, in some sense.
Well,
Which...
publishing negative results is also good.
yeah. Wait, see. Define is head. I just thought the started it kind of was more interesting to do on bigger models and started looking at bigger models. But yeah. Especially for course pushes that this is more important. No es handing do TPS towards okay.
Oh, I see now. Like it makes sense, the copy suppression. Wait, it's a bit different, I think, than regularization. Like it's always 100% accuracy, so it doesn't matter. But when you do cross entropy loss, then like even if everything is 100% accuracy and the probability is slightly lower, then you just get lower loss in the cross entropy formula basically. So it makes sense to create the copy suppression even though you're already 100% accuracy, because it just decreases loss. Even if it might not be
No, sure, I
doing anything.
understand. Shouldn't it decrease loss if you make the right? Shouldn't it increase loss if the number was even higher? The correct number was even higher, and the other ones were even lower.
Right. Fuck.
So it has to. It has to be that the model sometimes makes some mistakes, right? And then it's better for the model to be less confident if it sometimes makes some mistakes.
They say their model has 100% accuracy.
But
Wait,
maybe
what?
it doesn't have 100% accuracy during training or something. I don't know.
Then they say the model never reaches 100% accuracy. Oh, that's a different model then in the appendix.
Wait, does the model that has 100% accuracy not learn the copy suppression thing?
That's a different. Wait, I'm not in the appendix. It's if you remove layer norm, then you don't get 100% accuracy.
Yeah.
Model without ln. Okay.
The decision made the copy suppression. Particularly simple in the sense that it has more ingredients than before. To the simplicity, the model benefits of having two heads. And weight the guy puts the weights of head one down. It is however limited how much the weight of head can be if they have to limit the recovery. The model switch to having the heads cover the recovery sense, we have one makes a small adjustment to the sorting of head shoe according to our head. For simple set, pushes the weights into the subleading head down further by the circuit's order of magnitude below tossing into the head. Yeah, it's trying to make the if you do even smaller data sets, and I think this is also an artifact of the how long they train. If they throw longer, they will also see the same one. The top head just becomes even smaller. Is the saying. Start one head sorting. We saw the way number the subdominant head relative combination. Yeah.
No, it's slower because weight norm.
Yeah. Okay.
That's the loss.
Okay. They have no systematically checked for this dependence because differences can be seen in figurature. Okay. I mean, we did try at least a few different heads, that's okay. LLC is only defined local minimum, which models never are in practice. Okay, yeah, so the LLC is also sus. This other paper argues that LLC value is not trustworthy, but relative wording LLC is different state of training. The LLC property sets the science and proper use heuristic of seeking property set. Yeah, okay, don't trust LLC too much,
It's a heuristic.
especially with the
Well,
one
it's a-
study.
yeah.
But okay.
I guess heuristic makes sense.
Represent
Or approximation.
Okay, I don't think they show that they thing actually generalizes to bigger models. They just allude the kind of so vague, something vaguely similar, bigger models. But that's the other way around, where they already had something that does copy suppression in the bigger models, and this here, I don't even think the copy suppression here is even the same thing as necessarily as the bigger head. But maybe it is. I'm curious. Yeah, I guess it's interesting that models will be interesting for Remote to figure out if models do this often. Why this happens? Like why, for example, why is the model doing it this way instead of increasing here or increasing on both, right? I guess. Okay, no, I guess it makes sense because this way the model is increasing on the bottom one and decreasing on the top one. I can decrease the top one by making it closer to zero,
Uh,
and the other one around wouldn't work.
close. What do you mean now?
So if it had the thing as the number becomes bigger, the loss will become smaller. The loss will become higher, right? Like it could
Because it's like norm.
simultaneously increase this one and decrease that one, but I think it's better if it decreases one of them. So
Yeah.
I think it's better if the one where the norm is decreasing is decreasing the number that the model wants to be higher.
Yes. It's like regularization.
Like it could also do it the other way, but where it decreases the number and at the same time increases the other thing. But I think it's like the slightly prefer, and there's probably some massive reason why it tends doing this instead of the other way around.
Like it feels like it's like trying to find this middle ground between increasing accuracy and respecting weight norm, basically. So there are like two heads fighting. One is like
No. But
weight
the
norm.
way it works
No.
here, if it's decreasing, yeah, but if it's decreasing, both things are related because it can. This head can, as it gets lower, it might increase accuracy.
Yes, but weight norm. Weight norm that takes an absolute value. So you want it to go lower as well. Okay. You want both to be lower.
Yeah.
Or like absolute value
And
square.
if this one was higher, you might. It kind of depends because it is also the thing where the model might have. I guess there's another thing that as the model gets more accurate, you get less cases where the model is wrong. And in the cases where the model is wrong, you want the number to be lower, and the cases where the model is high, you want the model is correct, you want the number to be higher. So there's probably
Yes.
something related to that.
Yeah.
I feel like maybe you could see something interesting, like plotting how this develops here. But but maybe they plot it down there. But we had a nice animation. But I can guess if they did it, it's probably because it's actually very annoying to deal with because it takes all of your compute. If you are in a university or just this space, and if you're in university compute, you might have very limited stick space for you because everyone is using it or something. I mean, these kind of tiny models are okay because they are like very tiny. It depends on how wide they are. Like if they what the T of the model. I think it's just 36, so it's probably not that bad actually. It's probably only a few kilobytes, so it's not that bad, but still, it also takes longer to train and stuff because you need to steroids. Yeah, it's probably not that bad. I think I was thinking more on my thing because I was using bigger models and maybe I over exaggerating how problem they are, and they should have just saved more steps. But maybe they were saving more steps and they just didn't want to plot all of them or something. Also,
Yeah.
another thing is here is that like this is a different order. This is a logarithmic plot on the x-axis too, right?
Oh. 0.5. Yeah, it is training steps. Interesting. That's logarithmic, yeah. Also, I just asked like Claude like what's the role of copy suppression, and Claude is looping in. Oh, it's this. No, that's false. No, it's no incorrect. Wait, let me revise. No, wait. Like so, we're doing the same thing like Claude right now. It's funny.
Yeah.
Just goes on and trying to still shows helps conclusion
I think
after
that
extensive
again,
calculation.
that also happens when you are doing this kind of research on tiny models. But the nice thing about
Yeah.
these papers and the thing was that you can just keep reading or doing more experiments, and you eventually you realize you were wrong. Where on
Well,
other things where
yeah.
you have less shorter field values, you maybe get the wrong idea and then never learn you were wrong.
Yeah, I wonder how reproducible this is in different contexts. A lot of the claims.
Okay, so orbit head. I'm like just quickly looking at the appendices, but I probably should end it soon because we've been for 4 hours. I'm kind of tired, but yeah. I think most
Yeah.
of everyone else just left anyway. I hope they weren't too bored. Maybe next time will be more interesting for them. But yeah.
The new paper, for instance.
I think. Oh yeah, remember it's still there. Yeah, but it's okay. I get the impression. Remember, I get the impression you probably also wanted to talk about other stuff. You are not
Me?
that interested to keep talking about the paper. But if
Me?
so, sorry.
Or Rembert? You mean me or Rembert?
I mean, Redbird, yeah. I think you are.
Okay.
The reason we keep going is also because you're also interested in this thing.
Yeah.
But it's also maybe just a us thing that me because I was interested in this kind of toy
Yeah.
models.
Okay, I think I also now see the QK heads more. Oh my god. But the copy suppression thing is still so confusing. And Claude is also extremely confused. We're all confused about it.
Yeah, I get Robert is another more controversial interpretation. I think that makes sense. I do think maybe this kind of toy model research will turn out to be useless, but I'm not that sure. I think Neil thinks it's mostly useless these days, though. But yeah,
I like it.
I like it too. But this might be the
Like
kind of thing
the
that's very fun
university.
to get the nerd snipe on, but not actually
Yeah.
useful for safety or whatever, or for
Like
actually
I believe
understanding
in
big
the
models.
I believe in the universality hypothesis, for instance.
Yeah, that's true.
So
I have. I mean, it's probably more complicated, right? It's not like everything generalizes, or some things are way different, or way
yes,
similar, and it's more. The actual thing is more complicated by that. Like
finding out what exactly are the domain specific
yeah,
what exactly are the
I
general
think a
patterns?
promising thing is looking for cool geometric structure on the toy models too. But
Yeah. Oh, do you see this? Do you see this graph on the right? Do you remember the? It's circular again. The
Yes, like yeah. Whenever I
this
see
is
now a thing with different bands or different colors on periodic patterns, I think this is kind of a
oh yeah
circular thing.
yeah
Maybe, but not only that, these ones too. Like right on the squares with the suppression, it does suppression on like periodic intervals. Which kind of looks like it's maybe putting the models on a circle and like putting the numbers on a circle or something, and doing a thing where it suppresses, it increases one direction and suppresses the opposite, right? Like it's just putting the numbers on a circle and increases a direction, and then the other direction gets suppressed, which is how you do this kind of thing in a linear way.
QK should be just attention. That should be just what's the next
Yeah, but I mean on
bigger
this is the
number.
OB circuit here. I mean on the OB circuit,
Oh,
right?
okay. Oh, yeah.
So
Yeah.
on the OB
Okay.
circuit, you see that it's red, blue too. A bit.
Yeah. I
I
see.
think this might just work by you put the numbers on something like a circle, and you increase one direction, and then the opposite direction gets decreased.
Yes.
And you probably need a third direction, right, to make so the current thing, like the this is more than these other lines where it comes back, but still, there's probably some kind of spiral thing too. Like has a third dimension. Or it doesn't need to be like that. Like I plotted for the modular multiplication model, and it was, I think, not a circle. It was another structure where it was just more discrete and like clustering numbers based on the number module or something. It's maybe something like that. But yeah.
I see.
But yeah, there is
Yes.
some geometry of the numbers where they are on different positions periodically based on some.
I think so. That could be plotted
Yeah,
somehow.
you plot. For the modern thing, I asked Claude to tried asking Claude to plot it, and it made a nice plot for it. You can just do the thing they did on the circles and spirals paper, where they the anthropic one that we talk about a lot, where they do
Yeah.
the PCA and you plot the PCA. And if you do that on the modular addition, no, this make this plot. I have. I have it here. I was doing it yesterday, so I have too many clothes experiments. I was trying plotting stuff. You get stuff like this, but the nice
Did you
one.
just do this from the paper, or was this from your previous paper?
Oh, this is for a research I was doing the other day. I just saying you should be able to do the same plot for the paper, but you do the PCA and you get. Well, I did too many plots because I was trying with plot.
Yes.
But
Plots are
there is one
now.
that looking nice. Oh yeah, you get something like this where the numbers are like in different clusters, right?
Ooh.
And if you look at there is another one where it shows like how the lines.
What do you think is
Your mic, Hava. Yeah. I think it's wind. I'm not sure. It's wind, I think. Yeah.
Well, I'll find the right plot later and maybe send it to you. But there is a nice plot where it shows that the actual like that is just some periodic thing where it's just like each cluster is like the number is 5, like something mod 8 or something, right? And like if you look at, there is some other plot where you have a line in order of with colors in order of how the number line works, and it's just going through each, like it does a thing where it goes through each clustering periodically, just traces the same path a lot of times, and it's just each cluster is just when it happens to fall on that one, and it can use that
Okay.
to, like, it has a bunch of dimensions and it has a bunch of clusters like that, and with a few of those it can separate all of the numbers because they all fall on different mod clusters for different in different directions, and it has like 6 directions, and that's enough for picking the numbers up.
Interesting.
And actually, this is the modular multiplication. It probably does the same with the modular addition, because it gets you the same Fourier decomposition too,
Huh.
but it's
Okay.
just a sum of a few Fourier components.
So that sounds like a positive result.
Yeah, maybe. Not
Hmm.
kind of completely unrelated to the rest of the paper though.
Oh, yeah. Do you have any pieces of Fourier papers? I keep on seeing there's a lot of them. I just haven't read all of them. They're like a comprehensive list. There's too many of them.
The one we are referencing to is progress. This one that we're constantly referencing. The
Yeah, just the Grokking
yeah.
paper. Anyway,
Modular addition one.
going back to this. Yeah, that's cool. Red, blue, nice. 3-head model. In the 3-head model, why did they? Oh, here it's all 3-head that way. It's weird that on this in this one it seems like it's smaller, right? So it seems like 2 heads. It's interesting in this one. 2 heads do the the splitting thing, and the 3rd head is doing the lower numbers thing. Actually, this might generalize. I wonder if when models want to have a head, want to make a diagonal, and they have a head that that doesn't do anything, it tends to end looking this way, where the head is like in some sense working opposed to what the model wants to do, and it's decreasing in norm.
Head free. I see. Yeah, it's suppression. Okay, wait. So what happens here is that you have first head is specializing on like 20 to 30. The second head is specialized and also in the beginning. The second head is specializing for the rest. And then there is this general suppression head.
Yeah, but
Okay.
the suppression is just much slower, and it's doing the thing. It's probably as it trains, I expect it gets increasingly lower on the thing, right?
Is there a 4-head model? Yeah. Does that split? Does that make the copy suppression split?
Oh, also, yeah, I'm thinking. Okay, so what if the QK mechanism sometimes makes errors, right? And when it makes errors, it increases this, and when it gets it right, it decreases this. So it strains, it goes down, but maybe at certain steps it goes up.
Okay. Error management as well.
Yeah.
That makes sense.
So this is. And this will be related to because that was what they were saying, that the error management thing, that the confidence adjustment thing, it was thing.
Oh my
That's
god.
a very interesting mechanism, because there's a natural mechanism. I didn't actually figure out how it forms, but it seems like a natural mechanism for getting the set to. When it gets something wrong, become less confident. When it gets something right, become more confident. By just having this, it just like it could also do that on the other hand, like just increasing the number or decreasing the
Yeah,
number.
that makes it. Like I think it does both basically, and by
Yeah.
doing both, you are like going on the loss much faster basically.
Yeah, I just curious why those why this is favor versus just here have a full diagonal and increase it a bit or decrease a bit too. But I can see why there's something with the norm where decreasing the norm is probably better than decreasing
Okay.
the norm as you decrease the thing is easier or something. But I get that it's easier, but it's not like gradient is local, so there's also interested in how this starts happening, right?
Yes.
I also start happens just every time it gets it right, it just decreases and it also decreases the weight decay. But how did gradient set end of this thing? Or did it just randomly change things and it just found this one that randomly that it
I
just
think
happens?
it makes sense. I think it makes sense, like,
Is this like
because
rocking
if you have
paper?
something
Is this like
wrong,
rocking paper?
Yes, the one that was linked was the working paper, yeah.
yeah, I think it makes sense because if you're wrong, then if you simultaneously increase confidence in correctness and decrease confidence in incorrectness.
Also, yeah, this is the 3-1. I'm
Yes.
curious about the way
Also,
the guy. Okay, baseline to the model. What's the way? Let's look at the way the guy one because doesn't it happen without way decay? Is the thing.
there's also forehead model, and that's the evolution at page 25.
Oh, they don't show.
Yeah,
They don't plot it.
25. 25 is plot.
Okay.
Oh yeah.
Forehead
So like
model.
this is so weird. Like first it's like basically noise, everything starts to be the same copying. Then suddenly like you get one head doing nothing, another head doing just copy suppression, another head doing half, another head doing half. Then it's like fuck it, another head emerges with another specific head, just copying the head free. And after that it's like no, there's gonna be one general head for copying, one general head for copy suppression.
Also, we
And
haven't
then
been looking
two
much at
specialized
the QK circuit, even though it's
ones.
actually the most important part of the model. But yeah, I
Is
see
it?
just kind of all of the same.
I feel like it. Yeah, I feel like it's just this. Yeah, like look at bigger ones and upweight them, and the closer
Yeah.
the bigger ones are, the more
I'm
you
curious
upweight them.
how it actually does that, but I guess it
And
can. I guess
yeah.
it's also probably maybe a circle or something, or like some modulo thing where it
I
stores the
think this is
modulo.
like, yeah, like I think this is splitting it on like different frequencies basically. When you sum them together here, you get like the normal shape basically, where it's like where you are bigger
Yeah.
gradual decrease, which is happening here. There's the gradual decrease the more you go up.
Oh, we should see that on the wall one head one then. Yeah, kind of. There's a bit here which makes me think it's also using some kind of circle, and that's why it has this.
Yeah.
Or at least some periodic structure. Let's say that.
Yes.
Everything
I think
is circles.
it's different
Spiralism.
since the different heads are like discretizing it basically. One takes 10 like 10 to 20, another takes 20, 30 and so on. All this in a discrete way, like
Yeah.
modular way basically. Because why? Yeah. Because gradient
Wait.
descent. Well, okay, that's interesting.
What is this? Oh, without layer norm.
Okay.
Okay, so we
Okay, I
are
wanna see
ignoring a
that
thing,
now.
which is layer norm is a thing on the other ones, and layer norm is technically a non-linearity and is maybe using it for something.
Huh. And yeah, and the loss
Is there
also.
any evidence for nonlinear features though? I thought like Othello GPT, like the example of nonlinearity from there was actually proven to be linear features. I thought there was no evidence for nonlinear features.
Oh, no, I mean models. Even if the features are linear, the models definitely do non-linear things with them. Like the ReLUs are a linearity, and if you want to do, for example, if a feature exists and this other feature doesn't see. You want to do conditionals nicely, you need nonlinearities.
Aha. You see, there's no copy suppression here. So the weight norm is incentivizing the copy suppression. So it's
What?
like, okay, in this graph that you're looking at, there's no copy suppression.
What's going on here? Like, what? Why the squares? I don't get it.
This is only at the beginning.
Okay, and later it goes from these weird squares. Or maybe it only can do this because it's linear and
Later it makes sense. This is
Okay.
this is just first training steps.
Okay, then it does this kind of weird thing that kind of somehow works. But it's
Wait, you're
still
looking at different graphs. Baseline to
Oh.
head model. Baseline to head model without
yeah,
LN.
okay, so
And VD. Wait, what is VD? I forgot.
wait, okay.
VDK, okay.
Wait, so
Ah,
okay,
okay.
which one is which? Okay, let's say for baseline to the head model without layer norm and weight decay. Or without neither of them.
Yeah, that's without LN and YDK. That's the figure
So the
15 on
first
page
this one is
28.
without the layer norm and the weight decay. So but this one just does the same thing on the QK, right? Kind of seems similar. And the OB, it starts doing, it does the splitting thing, and it does suppression on here, and then not. But
Like
there is another head that is doing the opposite of suppression. It's doing the positive version.
Yeah, this is the general copying, and then the other two heads are like specialized
Splitting.
for different ranges copying, because why not? But what
Yeah,
fascinates me is that in all of those graphs, there is the copy suppression head never specializes. It's always general from the ones I've seen so far, if I haven't missed something.
Oh, but this says, okay, forehead model trained on, but this is the forehead, wait, what? Figure 12. Forehead model
Yes, foreheads.
trained on, but this is trained without weight decay or layer norm, right?
No.
No.
The first one is with both.
Okay.
This one is with both. And the
Okay,
ones
this is
under
very
8.
okay, so this is just the loaner for layer model. Okay, so this is the one without layer norm, right? It's also without the layer norm and without weight decay. No, okay, it's only without layer norm. It has weight decay. And it does this completely different weird thing then.
That's funny. Yeah.
Which, what the fuck is going here? Like, it's not, it can't be that good, right? Because it's not, right? It's not even completely for all the numbers doing the. I guess it kind of has to do, like, it has to do some kind of linear.
Yeah, there's no
suppression.
normalization to the mean and standard deviation. So it just goes haywire. The gradients go haywire. It's not regularized.
It still ends being this.
What
but
is happening?
It does work. It does this weird thing. Okay, so circuit rag goes down very fast. This actually,
That's funny.
They at some point kind of does something like it does grok. This one does grokking at the end. It doesn't. It's not that you have.
It feels like it underfitted at the end, at the beginning, since all the dimensions collapsed the ring.
Yeah.
And then it's just like, wait, I'm actually not gonna underfit, and
then it learns
saved
whatever
itself.
this is. I mean, this is okay. Then we had this kind. Okay, this is just okay. This is just on the OB. Is again the splitting thing. It's just much worse, like a much messier.
This is the weirdest split, and it's like, oh my god. Why does it split
look
like
at it.
this?
It's just if you see. Okay, so these more steps. So it's just it's not just. I like this one. It's just the diagonal of this one. It's that this cross that is on this head for some reason.
How is the cross so exact? What?
Oh, but the thing, the cross is some specific numbers, right? So it just learns those numbers. Like there might be some example of the dataset where it has those numbers and it hadn't seen them before, so it learned them separately or something, right?
Yeah. And it's
I
still
wouldn't be
just
surprised of there is some list on the dataset with only has numbers from this. Happens to have numbers from
okay,
this.
makes sense. Yeah. And it's just specialized
It's
for
probably
this.
like
Okay.
this kind of thing that you run it with a different sheet and it looks different, I guess. But I think they also tested that.
This is
But the thing
crazy.
is, on the
Wow.
QK circuit, it looks like a mess. I guess it still works because his style has a bit more like this. But on this step, no wonder it was that very bad on the loss because
The,
this doesn't work.
the cross is being grokked, basically. Oh, Jesus Christ.
Oh, you also look like there was a bigger cross here, right? This guy
Oh, yeah. Okay.
kind of narrows
Oh.
down later.
Oh. It just first completely diffused, and then it started to somehow make structure from the diffused stuff and started converging on the loss. I wonder if you would train it even for longer, if the cross would just get smaller and smaller until it vanishes.
Maybe it got smaller and this one starts being like blue on the middle.
Hmm.
Are
But this
blue
is
the negative
also
activations
for
and then the
yes,
red is positive? Yeah.
yes. Also, this is 4, right? So the on the 4 dataset, the original model didn't learn the original thing on the first plot didn't learn copy suppression.
Hmm.
So maybe it's because of that. I wonder also if this is just
Wait.
it will learn it later and they just need a different weight decay or something, or 10 to the power of 6 steps that they didn't do.
Ah, okay, I see. Yeah. Oh, wait. But what was the one before? Without FD, without LN.
Yeah, this one was without layer norm.
But it learns copy suppression when it's forehead on top.
But wait, forehead on which dataset? The 4 one. Oh yeah, but the 2 head one on the 4
Doesn't.
dataset doesn't. Like on
Yes.
the on let's say
What?
on this one doesn't. And I suspect this is just it will learn it later, but it takes more time when they only did 10 to the power of 5 steps.
Probably.
Right,
Yeah.
because the 2 head one on this on this other dataset, the smaller dataset, does the thing. I think it's related to the fact that here this is like more has more splits for
Like
reason they explain later. Right? So it's
maybe
easier
if you
for
yeah, like maybe if you would try different hyperparameters, the two-head model on this two data set would learn one. Wait, there's just one head. No, wait.
sorry.
What is the
No, yes,
first? What is the first
two
model?
heads.
Yeah, and the on top there's just one head.
No, there's
Okay.
2 heads.
Well, you baseline. Oh, okay, but it's a different data. Oh, right, different data set.
Yeah.
Right. Okay.
I suspect it related to this square. Like it's easier, it's harder for the model to go from these small separated squares to the copy
Mm,
head than from this mess with like more tiny things, right?
yeah.
And they do explain why. They have a hypothesis for why this splits more with the smaller dataset, and they have a thing here about the
Yeah, I've seen
gradient.
that. Yeah.
So it makes sense that and on the other thing, okay. So going back to the thing, I want to see the weight, the one without weight decay. What does happen without weight decay is the thing, and so it seems it has okay. So what the circuit rank is kind of funny. Okay, so
Mm.
it's just Whatever.
I guess circuit rank never went down without weight.
Okay.
Yeah,
Looks like almost an error.
Yeah, whatever the circuit, just doesn't go down. Like the way the K was making it go down, I guess. By making
What does
some,
weight decay do again?
it makes gives the mother more loss the bigger the numbers are, right?
Weight decay or layer norm?
Where the K?
Are you asking? Okay, yeah, weight yes.
Yeah, like it's just if I remember correctly, you just add the L2 norm to the loss, right?
Yeah, it's just some hyperparameter scalar times the sum of all the weights squared.
Yeah, it's the sum of all the weights squared.
Is that automatically added in the optimizer, or is that like something you have to
In the
add on
loss.
to the optimizer?
Yeah,
No,
you
for the
just
loss
add the
argument.
Add to the loss, yes.
Is it like in automatically in atoms, or is it like just some part that's like additional thing you added?
I think in Adam you can add with the like the usual, like normally you can just add it on the loss, but I think on the current implementations of more optimizer they have some option to add with the K automatically. But yeah,
like
it's just
Adam V, which most people use, is using decoupled weight decay. I think that's the we know.
Yeah, they sound similar to what Atoms does. So I guess weight decay was just a separate thing. I just consider it separate.
I think Adam by default has weight decay.
Yeah.
But
you can think of it as separate. But yeah, I think the actual implementation of Adam might actually come with
weight
decay.
and you can make the weight decay 0. It's a hyperparameter. Like it's hyperparameter times this weight decay. So if you just make it 0, then
yeah.
you
But
have
what
0
this doing
weight
is
decay,
just
basically.
adding the square of the weights to the loss.
Yeah.
Okay, I see. It's to penalize. It's penalizing for high loss, weights.
Yeah, it just wants the weights to be smaller. Which
to prevent explosion.
It's also so the weights are simpler, because the smaller they are, the less information they have.
Okay. So it prevents, oh yeah, I see what it does. It prevents the exploding gradients and also makes it simpler.
Yes.
But they are here. They're showing that even without weight decay, the model has something that makes it makes it prefer simpler explanations than is memorizing everything and still learns the thing. And so learns it weirdly. Generalizes. I don't know if generalizes works because they probably use different. Yeah, they use different scales for the graph, which is a bit annoying, but still. But yeah, it also goes really pretty down, right? Because this is power of -1. Yeah, this is actually much lower than a lot of other examples.
And there's no copy suppression.
So yeah, no copy suppression, which might just mean that you need to train it longer for it to happen here, or might depend on might actually be a weight decay thing. I could see why it's a weight decay thing. Yeah. My main explanation is why it happens and why it's actually negative is are related to weight decay. So
at the same time, it's also dataset dependent. So yeah.
Yeah, also you're right. This is on the 4.1, and the 4.1 didn't have weight decay anyway.
The weight decay is status dependent because a certain data sets might activate certain weights more or less.
Okay. So
yeah, wouldn't weight decay penalize something for a feature for activating for
doesn't this doesn't do the splitting thing? Oh no, it does do the splitting thing. Why does it look nicer than with the weight decay? Oh, actually, okay, I get why. Do you know why it looks like this and it doesn't look like this mess?
Because maybe adding that extra noise penalizes the model because it has higher.
Because that's the other way around. This one doesn't have weight decay. It's just that this one doesn't have weight decay, so it's free to put the correct numbers to 5.
There's a big number.
So the weight decay probably the noise is still here. Is just out of the it doesn't see. We can see it.
Oh, is this how the model would normally show it? It just the weight decay forced it to put it in some weird arbitrary manner in order to get around the weight decay.
No. I just think it does the same pattern here than it looks the same here than it here, right? It also has this weird noise. It's
Yeah.
only you don't see the noise here because the noise is 0 point something, and here the maximum number is like 5, and here is 0.01 or something. Like it's just
Okay, so the weight decay
I
makes
think
the
it's
noise
just a
visible.
scale thing. Yeah, I think it's
Okay,
just
so
the scale is like the correct number is so much higher than the noise that you don't see it. On the other one, the weight decay is preventing it from increasing it that much.
did the original paper that we looked at have weight decay?
On the Grokking paper, which one do you mean?
No,
You were still
the
looking
one
at
before the Grokking. I mean the one
Oh,
we
is
did
it?
before the Grokking.
Oh, this is still the one before. This is the one before the Grokking paper, though.
Oh yeah, so that one oh so that makes
We were talking about the Grokking paper because it was related, but we haven't switched the one we were looking at. Though. This is just the appendix of the other paper. Sorry. Wait, okay. I also like that in this higher contrast, like removing the weight decay increases the contrast of the graphs, which is kind of nice because you you see the
Yeah,
more
you have
important
much bigger
things.
numbers.
Yeah, maybe
Much
you
less
will want
discrete.
to look at the other one. But these ones were still like without the layer on were still pretty big, I guess. I guess with the layer norm also like without weight decay, but with layer norm, the layer norm is still doing normalizing. So maybe this 5 is much higher than 5, and then gets normalized. So the one
Yeah,
without both I expect to see before seeing a print, I'll see insane numbers. They might have
it's gonna be
problems with
complete chaos.
getting nuns. Yes, okay, it's 50
Oh,
already
100.
here, so
100. Oh yeah.
Yeah, okay. I like to be able to predict what's going to happen next on the paper.
And the more you train, the bigger it is. Oh yeah.
Yeah, I was doing things like that at some point. I got in nuns. It gets crazy.
It could be funny if it would. Could be funny if it would overflow and suddenly it turned into copy suppression. Oh.
No, it just crashes because you get a nun when it gets high enough. Like it doesn't. It
Yeah.
overflows into when you the PyTorch overflows. You get a
Oh
nun
yeah.
and it throws an error. So it's yeah.
I remember getting some error like that. Yeah.
Yeah, I got it in the modular multiplication thing because I was trying things like removing layer norm and changing the weight decay.
Yeah.
Or I was trying. I made I tried making insanely high the learning rate.
Oh, you're
It
talking
was
about
just
unlearning rate? Which unlearning method are you talking about?
I was just doing Adam with a very high learning rate and see what happened.
Oh, you were doing Atom? I tried using RMU and stuff. You actually, I noticed that if you do like samples like around like less than 100, it didn't really unlearn. I tested this by like looking at the
Yeah, no idea about that other learning stuff, to be honest.
Oh yeah, I so far all the only code I did so far was like get unlearning to work with max entropy, RMU, and MPO, and then I tried using SAEs to like steer it after relearning.
Maybe we can at some point read an unlearning paper and you can explain it.
No, I'm making the project right now. Making an unlearning project.
Yeah, no, but I mean, we can read some other paper on unlearning, and now that you know a bit more about that, you can be the one reading it or something.
Oh, sure. I don't mind doing that. I've been reading unlearning papers for a while, trying to like understand because currently SAE Bench is the closest to an interp-based unlearning method.
You can become the unlearning guy on the server.
Oh, why? No, that's my current project. I made a transcoder steer, and I'm right now trying to see if it works with unlearning.
So
I'm also using model diffing.
On the one without bolt also. Also, the one without bolt is because it also does the weird squares thing Although the loss goes down earlier, but yeah, I guess.
Yeah, but
This is the one without the decay, right?
10-2.
Yeah, this is
The
without
loss goes down pretty
the
early.
decay and without the layer norm. So it does the weird squares thing, and then it does.
So it seems like layered.
I wonder what these squares are and whether they are so low. Like, it seems like there must be some, basing thing where models. I seen them on other models at the start. I even seen them on Bath image generated models that were not very trained generate this kind of things. So
How did they initialize it? Like a random
I mean,
or
normally it's
some
just random with
distribution?
some Gaussian noise, so it's
Yeah.
but it has low LLC. I wonder if there is some reason why, like on the first steps of a model, start looking like that. Because at the start it will just be
Yeah.
kind of random, right? But it's kind of
Yeah.
there's some more structure here than that. It's very structured. Some squares. I think there's probably some reason why these squares happen, but yeah, I don't know. Maybe there is some paper about that already, but yeah. Like,
It
okay,
should
so every
step
over
something.
here,
Yeah.
yeah, and then the QK kind of starts becoming the thing from being a mess, and you can see how it swaps from the squares into this slowly. It probably looks nicer as an animation, but we don't have the code, I think.
Yeah.
And I mean, it's
Then it
actually
slowly
wouldn't be too
crystallizes.
hard to ask Claude to train a model on this, but right, to replicate the paper. But yeah.
Oh,
I
you're
was
gonna
happy
replicate
about
the
that.
paper
Yeah.
after? Like
On
you're
the
gonna
other-
replicate the paper after this?
Like first thing
Maybe.
I kind of wanna do is ask the authors if they just have to GitHub
Yeah.
or something.
Yeah, that's
That
probably.
we just wanna play with it.
If
If they
Have the
can give it to us.
GitHub? Yeah, I'm gonna go ask. If you have the GitHub to be shared on the server.
Also maybe there is. I think that there might be something from the original thing, right? Like from this. Or
This is from an
like,
arena post for the
Okay.
Mech Interp challenge.
the Calum. Yeah, the Mech Interp challenge. Maybe there is something with the code for all the Mech Interp challenge stuff.
Oh yeah, what are Mech Interp challenges?
What algorithm problems? Also, how long have they done this? Okay, they still, or they live for a few months in, like in 2023, and then kind of.
Years ago.
So they stopped doing.
Yeah, they stopped doing it. I guess they probably they weren't getting a lot of people. I guess. I didn't know about that. Otherwise, I would have linked it on the server or something.
I didn't do the Mech Interp challenges while they were on because I didn't know about them.
Same. I don't think anyone of those. Okay, they were on. Okay, they were part of the arena material. Yeah.
Yeah, they are pretty embedded in.
So I guess they
safety
probably did
community.
it for that session of arena, and they haven't kept doing it, or maybe they did it on some other thing that was not this. As people got less interested in this kind of modular, of algorithmic tasks, and people started being more obsessed with sparse autoencoders, which feels like it has been for a while. But 2 years ago it was not that big yet, right? Like when did this?
But this paper is 1 year old. Or
Yeah,
maybe
but
it's older,
I feel
but
like
just
this
released
paper,
on archive now.
was already building of the. I feel like these people did arena 2 years ago and then spent 1 year building on the arena thing, right?
Yeah. Makes sense.
Okay, so anyway, that makes sense. I don't know what this is. Vocabulary size increased. So it's kind of the same, just bigger. And here it does weird whatever this is.
So weird attempt to specialize.
What's the intervention on this model? What did they remove from this model to get this?
Oh, this one is bigger. Like has more number. Like have.
So this is what increased the vocab size. I see.
Yeah.
I find the appendix a lot more.
meeting-
Surprisingly, the appendix is a lot more interesting than the table.
Yeah.
Lots of different experiments that show you the whole state space more, yeah.
Yeah, I think the interesting thing about this kind of thing, precisely to be able to look at a lot of different, kind of changes, and
Yeah.
it's kind of. I feel like the paper would be better if they did more of this, and then the main part of the paper was plotting some summarized thing of, adding together a lot, have some more plots with a different weight the case or something, and plotting for, systematically plotting for different weight the case. Maybe that would
Yeah.
take too long to train to do more systematically. And they do mention they could do it, but more thing. Yeah, that's cool. Especially this then in case 20. They okay, so they also did 20 bigger.
Hmm.
So with bigger least length, it does this thing.
Even more discretization.
Yeah. I think
That's
this is
weird.
also like all of the models are the same size, so they have to use the same amount of weights and weight decay or whatever to
Oh yeah.
do more regions. So it's probably why it's kind of this. It's probably related. Oh, is
Yeah.
this one big? Okay, base head perturbed version. A perturbed version of the. I don't know what it means perturbed here. Probably they add some noise or something. Okay, yeah, they probably add some noise because there is these things here, right?
Maybe.
Like it's probably spraying on the upper thing where it displays the different.
But how do you write that word? Perturbs. Vocabulary size splitting model can be smoothly patterned towards suppression by gradually reducing the size of the vocabulary regions covered by the head initially, covering the least of the vocabulary. As the regions covered by the least dominant head shrinks, the other head gradually takes over these regions before shrinking vocabulary
I
vanishes
don't think
completely.
they explain it here. There's probably a thing where they forgot to to explain it, or maybe they explain it at the end. The perturbed version, like what the different.
By gradually reducing, the size of the vocabulary regions covered by the head initially covering the least of the vocabulary. Okay.
Okay, I guess that's it, right? I mean, we're probably more or less the same, but I'm kind of tired, and we've been here for like 4 hours or something, or more, or 5.
Yeah.
So let's just leave and stop the recording and all that. Okay. Also, I hope, but I mean, the only thing is that's probably not that interesting for other people to watch us try to go through this. But I hope we didn't lose the recording because I forgot to keep checking. Let me. Still recording.
Yeah, looks good on YouTube, I think. Yeah, it looks good.
Okay, yeah. Let's stop it then. Stop recording.